right, no worries. No, and I'm not here to sell apps. I'm here to teach people how to find flat Earth information, and the app is the answer. So we'll get there. You're using OBS.
You might be muted. Yeah, no audio.
Second. I see why. I changed that. Yeah, no, it's all good. We're going to go ahead and do that one again. All right, my bad. I apologize, guys. I got you. No sound that one. That was a rookie mistake on OBS. I swapped out my mic 2 days ago, and I didn't switch this one profile over with the default settings. So anyways, good morning, good evening, good afternoon, wherever you are in the world. This is Conversations on the Fringe. I'm Josh, that's Jason. That is our guest tonight, Dave Weiss. We're going to be talking about flat Earth. Is the Earth flat tonight? And, let's go a little bit into this. And see, we talk about a lot of varying topics here. We talk about the paranormal. We talk about UFOs and aliens. We talk about major conspiracy theories. And see, the reason we do this is not that we necessarily believe in them, but it's always good to have information coming at you so you can determine for yourself what is real and what is not. And one of the mottos that we have here at the Redpill Project is never believe anything anybody says, no matter who they are, whether it's Dave, myself, Jason, it's Donald Trump, or it's your pastor or your priest, or whether it's a book that you read. Unless you can prove it yourself with your own volition, with your own research, and with your own belief and experiences. And I hold that true. And that's one of the reasons that Dave had reached out to us. And I'm like, you know what? I'll bring him on the show. I want to talk to this guy, and I want to see what he has to say. Because you know what? Maybe he can change my paradigm. Maybe he can give me information that I didn't know. Maybe he can show me something that just changes my paradigm a little bit and betters my life. And so for those who don't know, Dave believes that the Earth is flat. He believes that NASA lies. I kind of agree with that one as well. And
I agree with that one.
Yeah, we all agree with that one. He's the founder of the Flat Earth Podcast, also creator of the Flat Earth Sun and Moon and the Zodiac Clock app. Dave, how you doing tonight, man?
Hey, I'm doing great, guys. I'm excited to be here, excited to talk to you. And we are going to change a lot of things. We're going to show you new information. And I say to every show, don't believe anything I say. I'm just going to show you guys some doors. I'm going to open those doors. It's up to you to go through and look in. And as my favorite podcast of all time, Crow 777 Radio, that's Crow with 2 R's, he says, belief is the enemy of knowing. Belief is easy. You guys believe lots of things. Somebody will tell you something, and you believe it. Do you know it? No, you don't know it until you test it yourself, just like you were saying. So I don't believe... there are people that believe they live on a globe, but they don't know it, right? I believe the Earth is flat, but I don't absolutely know it. But what I do absolutely know is that we don't live on a ball. So today, I'm going to take away your ball, so don't get upset. Nobody likes having their ball taken away. But aliens and stuff, I'm going to just change your paradigm, and I'm going to make them more real than they could possibly be on a spinning ball Earth.
Yeah,
Well,
before we start, I do have a quick question.
Shoot.
Does that mean the moon is flat and the sun is flat?
You're jumping right into it. We're
Yeah.
gonna go right there. So let me ask you a quick question. In your studio right now, look up at your ceiling. Do you have any lights in your ceiling?
Mm-hmm.
Do you? Look
Yeah.
up at them
I
and
do.
describe them and tell me what shape your floor is. The floor in your studio. Look at the lights and tell me what shape the floor is. Is there any correlation?
No, it's how much
My-
ice
my-
cream
my-
that people eat in the summertime with the amount of
My-
shark
my-
attacks that happen in
Right.
Delaware, right?
Right. My point is, the shape of the moon doesn't matter. But let's just jump right into it. See these these four spheres. Is that a sphere? Well, it's half a sphere. Is this one a sphere? Quickly, guys, before I pick it up.
No. Well, yeah,
It's
well,
not a
it could
sphere?
be. Who knows?
It
We
could be.
can't
Well,
tell. I'm not there.
So unless you can touch the moon, you don't know. It could be flat. Okay,
Oh,
you don't
that's
know
interesting.
what it is. Yeah. So
Well-
what I'm saying is, unless you can touch it and wrap your hand around it. But here's something.
But doesn't that go
I
for
think-
everything in life?
Yeah. But I think the moon is a sphere. I can't prove it.
Okay, so hold on a second. Just a minute ago, you talked about belief, right?
Yeah.
And I agree that belief is the enemy of knowledge. And the reason I say that is because
Of knowing.
of
Right.
knowledge, period. Because
Okay.
belief brings about a limitation. Anytime that we look at something,
Sure.
we tend to believe in it. We don't evolve that belief. We trap ourselves within that limitation of knowledge, right? So me saying that we live on a globe Earth is no different than you saying we live on a flat Earth, because each one of them has the same representation of relevance in the sense of belief.
Well, so yes, but there are proofs that show that we won't live in a ball, and we're going to get into them right now.
Ooh,
But
okay,
real
let's try
quick, for the people for the people that don't know what flat Earth is, the most of the people that mock flat Earth have no idea, actually have a misconception because they've been programmed into believing that the Earth is a disk floating in space. No flat earther thinks this. If you've Googled flat Earth, you go, I've heard about flat Earth a whole bunch of times. Let me Google it. You're going to end up at the Flat Earth Society. You're going to end up with all of the pre-programmed stuff that they want you to find, and it's all nonsense. You know, the Flat Earth Society, which Obama plugged a half a dozen times during his presidency, says that flat earthers believe that the Earth is rising through space at 9.8 meters per second, and that causes gravity. No flat earther believes that. Just globe believers believe flat Earth believers believe that. So if we're not a disk floating in space that you can fall off of, what are we? And the answer is we're in a pond. A pond is like a bigger puddle. A lake is a bigger pond. And the world ocean is a bigger lake. And
Okay.
what is the ocean, a pond, a puddle, a bucket of water? Every container of water needs what? A container. And that container needs to be higher than the surface of the water. Okay? So they tell us that Antarctica is a continent, an island, a continent at the bottom of our spinning ball, right? They tell us this is Antarctica. They also tell us that Antarctica is the highest land on Earth. That's interesting. Why is this island on the bottom, this continent, higher than all of the other continents? And the answer is because I just threw out my picture. You know what? Sometimes you miss and you hit that X and the picture's gone. So the picture I was showing you a moment ago, Antarctica is the shoreline that surrounds our world pond. It is the container of our pond. So we're looking down here. This is the circular pond. This is Antarctica, and it's the container.
Okay, so how
Right?
do you know that?
Because if you sail around the world, if you go to the end of the world, people say, you could fall off the world. There are people that have gone to Antarctica. There's millions of pictures, and this is what they call the ice wall. It's not a wall like the Game of Thrones, which is mind programming. It's
Okay.
just the shoreline of our world. And there's plenty of expeditions. Admiral Byrd in 1957
Very familiar with
went
it.
on TV. Yeah, and he said that he discovered more land bigger than the United States, filled with resources that no human has ever set foot upon, right? And filled with resources. Well, we're having wars for resources and land and
Now,
power.
hold on. So Admiral Byrd said this when and where?
So he, in the 1940s and 50s, they started exploring Antarctica because we had the technology to do that. And then as soon as he went on NBC television, I think it was NBC, whatever news show was back then, he talked about Antarctica. And all of a sudden, bam, the Antarctic Treaty went into place. A dozen or so countries signed on. Now they've all signed on. This is in 1959. The treaty can't even be questioned until the year 2041. No corporation, nobody is allowed to question it.
So well, hold on. Let's talk about it. So I was 10 years in the United States Navy. I've sailed the oceans.
Yes.
All right. So I've sailed the oceans. I understand about stellar navigation. I understand about what you're saying about Antarctica. I've been down to that level. Well, let's back up. So Admiral Byrd, actually, his son came out in the 1970s and tried to publish his journal. And this is where a lot of this information supposedly came from, pertaining to Hollow Earth and the massive land masses. Now, anything that we look into actual declassified CIA vault records pertaining to Admiral Byrd, none of this stuff was actually found there. Now, I've never seen the actual televised version of this, of Admiral Byrd actually saying this. Does any of that actually exist? That's what I'm asking.
Yeah, I've seen it. Yeah, you can just look it up. It's all over. It's still on YouTube. It's everywhere.
So he's saying there's more land than anything?
More land, bigger, beyond the poles, which is a problem on a globe, beyond the poles. So here's the question. What's out here in the outer space? Okay, in the outer space. This is the inner space. So if we live here, what's beyond the shoreline of Antarctica? And the answer could be absolutely nothing. That's it. We're in a dome. That's the end of it. Or there is no dome, and it's just endless land. I don't know, because I haven't been there. Neither have you. But there's speculation that perhaps this is Antarctica. And out here is extra land. Maybe land is also called territory. So this would be extra territory. If you live there, what would you maybe considered?
It'd be like an extraterritorial, right?
Extraterrestrial. And if you came to visit us in this inner space, where would you be coming from? An extraterrestrial from outer space.
Yeah, I can see that.
Okay, so they're always telling us what
but hold on,
the makeup of our world.
So my mind thinks through a scientific method. We just talked about belief as a limitation. So when I'm looking at this, I can't believe anything that is non-tangible. So I have to look at it and I have to be able to prove it. So how do I prove that? Show me. How do I go and say, okay, there's this thing there and there's this?
And here's the thing. Anything beyond the shoreline of Antarctica or anything higher than we can reach is speculation. And we don't need any of those things to prove that the Earth is flat. We're going to get into that. So this is an interesting map. Some people say it's not real. Some people say it is real. It has like 30 or more continents outside of Antarctica. We don't know what's out there. There's all sorts of stories. The Iron Republic, I'll show you about that in a little bit. Again, they're stories. Don't have proof. Don't need them. We don't need them to prove that we don't live on a ball. So,
all proof is relative, right?
Yeah. So you were talking about you navigated the oceans. So do you understand how circumnavigation works on a flat Earth?
Why don't you explain it to me?
So the way the Earth is set up, at the center of the flat Earth is our magnetic center. Some people believe there's a magnetic mountain there. Whatever it is, it's a magnetic center, and compasses need to point towards that magnetic center. So I'm pushing this compass west. West is a circle, equidistant from the magnetic center. Okay? If I don't turn, I won't be going west. Look, now I'm going east. I have to turn. So these circles are east and west circles. Now, this does not prove the Earth is a globe. Flat, because it works on a globe the same way. If I was a mile from the North Pole and I'd walk 3.14 miles and I'd be right back to where I started from. Now I'm going to try to dead reckon west. And if I don't turn to the north, I'm immediately heading south. Okay? I'm heading south. South is every direction away from the center. Okay? So here's the thing. Billions of people have circumnavigated east and west. 0 people have done it south, right? If I go south, I'll just go away. And on a globe, I should pop up over here as soon as
So you're saying 0 people have circumnavigated south?
0 people have. Now, they've claimed, there's Colin O'Brady, all of these guys that have claimed it. We look at their data, and none of it makes any sense. There's one pilot there was one thing just a couple of years ago called the ZQ pilot. And he said, he's going to go from here, North Pole, Alaska, California, out here to these islands, over here, Santiago, South Pole, and then he turned around and came back up through Brazil. And and they said, the weather was too bad at the South Pole, so we turned around. And he did it for the Guinness Book of World Records. And we're like, he's not going to get the Guinness Book of World Records. Well, guess what? They gave him the Guinness Book of World Record for southern circumnavigation for doing that route. Look at that on a flat Earth map. This is all he did. He went over here, he touched the point, turned around, and came back. That's what he got. Southern circumnavigation. Southern circumnavigation would be this. Go down here.
Well, hold on.
Magically
If that was the
show up
truth,
here.
then we would be able to show that with the actual distance traveled. The problem there is on a curved Earth, your distance is actually going to be different than on a flat Earth. So
100%.
Right.
You're
So
absolutely right.
where's the numbers to show that?
Okay. So this is they tell us Antarctica is 13,000 miles around. Okay, that's about what it is, right? So here's how you prove that the Earth is this is how we can end the flat Earth debate in one day.
Okay.
Get 2 airplanes with a whole bunch of people, fly them over here, refuel them up in the station, in Antarctica. One plane just flies around the coast, maybe 1,000 feet in the air, watching the coast out the left-hand window. This plane watches the coast out of the right-hand window. You and I are on there, Neil deGrasse Tyson, science professors, everybody, right? And we watch, and then 6,500 miles later, both planes will meet over here. But that's never happened. It never will happen because it can't happen.
Well,
so
but
the last person to let me just get to my point. The last person to try and circumnavigate around Antarctica was Captain Cook, and he went over 60,000 miles. It took him 3.5 years. Okay, I believe he did it 3 times. Okay, and it was 60 to 80,000 miles. So the only other people that have ever done it are this sailboat race. It's called the Antarctic Circumnavigation Race or whatever. But the thing is, they do it above the 60th parallel. So it's not even that close to Antarctica. And these sailboats that can go up to like 40 miles an hour, okay? Mm-hmm. They go around. NASA's GPS tells them where they are and how far they've gone. Well, and then they do the calculation and they're like, oh, yeah, we did it. World record around the world, around Antarctica, and we were going an average of 4 miles an hour. If you know anything about racing sailboats, they don't go 4 miles an hour, okay? and the reason it's 4 miles an hour is because they're just doing math. They're just doing math. They're like, all right, I went 13,000 miles. It took me 38 days or whatever it was. They divide it out, and they're like, oh, I went 4 miles an hour. Oh, no, you went 60,000 miles. Okay, I went 60,000 miles divided out. Oh, I'm going 30 miles an hour, whatever the numbers are. Okay, so there's some proof right there.
Well, that doesn't hold on. That doesn't equate proof.
I 100% agree.
Does not equate proof.
You want to prove the Earth is a globe? Fly my test around Antarctica with observers viewing Antarctica the whole time, and you can't do it because Antarctica is over 60,000 miles around. We
got my buddy right here. He's former military. He did well over 20 years in the military. He still works as a defense contractor. He's a former pilot, and he's a drone pilot currently. And he was part of Operation Deep Freeze. He actually went down to Antarctica. He's been on the surface of Antarctica. Myself, cool. I was taking orders to Antarctica with the National Science Foundation right when I got out of the military. Explain to him why he never stepped foot on Antarctica when he clearly has pictures of people who were there.
Absolutely. No, I'm not saying that at all.
Okay.
You can go to Antarctica and you can there's tons of areas. There's lots of people living there. Okay. I think there's more people living there than they're telling us. But Antarctica, I mean, if you just take this white area here between this line and this line, this part of Antarctica, that's hundreds and hundreds and hundreds of miles. Okay. Mm-hmm. So you're not going to be able to see out here.
So how tall is the ice wall then?
It's like 200 feet tall in some areas. Some areas there's no wall. It's the shoreline of Antarctica. I showed you a video before.
Well, I saw the little video that you were showing, and I mean, people can do a lot of different things with videos, and that could have just been an iceberg. But
I actually have friends that went to Antarctica last year, and they spent like $40,000 to go for 3 days. They were mostly only allowed on the boat. No one's allowed to explore independently. Right. And they showed them some ice, they showed them some penguins, and they kicked them out. Okay, and that's it.
I don't doubt that weird shit might be going on in Antarctica. But for me to look at this and perceive it as Antarctica surrounding us as a wall, and we live in this flat terrain.
Stop saying a wall. It's not a wall.
Okay,
it's
so
shoreline.
Shoreline. The shoreline. Right.
The shoreline.
Well, I come from the TikTok generation. I come from the TikTok generation. Yeah. I come from the TikTok generation where they flat Earth shoreline, right?
It's the shoreline, and there's billions of pictures of it at this point.
Well, I have not seen billions of pictures of it.
Google it. You can find it. They'll come up. They're everywhere. But there's videos, there's documentaries on it. But you never see what's beyond the shoreline. Like, if I brought you to the coast of Connecticut, you don't know what's inland on Connecticut unless you go there. Well, no one goes to the inlands, or what I call the outlands of Antarctica.
Okay. So I live in Denver, Colorado.
Okay.
All right. My elevation is 5280. I'm a mile up.
Yeah.
If I go to the top of Lookout Mountain, right, which is about 9,000, 9,500 feet, right?
Yeah.
So I'm a mile plus another, 9,500 feet, 2.5 miles, 3 miles, right? So I'm pretty high up there. With a good telescope, why can't I see that shoreline?
Because when you look through a pane of perfectly good glass, you can almost not see the glass. Many people have walked into glass doors because they're so clean. But then you line up 100 panes of glass, you can't see through it. You can't see a bright light shining through it because the glass will block it, and the atmosphere is the same. Here's an example. This is a famous viewing spot in Aluja, France, where out here, 175 miles away, is Mount Canigou, but you can't see it because the globe math, people are saying there's a horrible echo. Is that me?
We're not seeing it on our side. I'm looking.
Yeah. So
let me see. Let's take it. Do you guys hear an echo? I'm not hearing an echo, so it's not no echo 5.5 on our side.
All right, cool. All right, so
have that person refresh.
Yeah, Karen refresh. So 175 miles away, globe math from this altitude, the top of Mount Canigou should be a mile below the curve.
Okay.
That's physics, that's math, that's measurable on a ball.
Well, how we measuring that?
Because using the globe Earth calculator. Okay, so just hang with me.
Okay.
The light that's bouncing off of Mount Canigou isn't strong enough to push through the thickness of the atmosphere, but the sun is much brighter, and the sun migrates in between the two tropics, and twice a year it lines up with this viewing spot and Mount Canigou. And as it moves away, all of a sudden you can see Mount Canigou, and right here, the top of the highest peak should be a mile below a physical Earth curvature.
Okay.
But it's not. It's completely visible. It's not a mirage. As you see, the sun will go beyond it, and it'll actually block the sun. This is Mount Canigou. We're seeing it backlit by the sun. And if you have a globe, boats do go over the horizon on a globe. We don't live on a globe. There's another reason boats go over the horizon. But this top of this mountain should be a mile below the curve, and it's not. It's there.
So where's the sun going?
The sun is going away. So that's a good question. Let me show you my next thing, and I'll show you. It's all perspective. This is how it works. This is my flat Earth kitchen counter. It's flat, and I can prove that it's flat. And here is the path of the sun, and this is a level line. You guys can see that it's level. You have some discernment, but I proved it in the longer video. And I'm moving the sun across it. Now, this could be a city skyline. It could be trees, mountains, or just a cloud deck that's opaque, and the sun never goes below it. Now I'm going to show you the same thing. I have a camera on the other end of the counter looking up, right, from a terrestrial point of view. Now, if I showed you this first, I'd say, is this line tilted? And you'd be like, yeah, it's going down. And I'd say, is the sun going below this opaque barrier? And you'd be like, yeah. And this opaque barrier in the distance is at your eye level. It looks like it's at your eye level, but you know that it's way up in the air. And it's the sun just going beyond it. Now I'm going to compare this to an actual sunset over the water. Okay. Mm-hmm. And what we'll see is this is a real sunset. You think this is the horizon, but the sun is going to go behind something right there. Look. And what that is, it's called the atmospheric deck of opacity. As you're looking through the atmosphere, it becomes opaque, and the sun just goes beyond it and appears to set. That's why it looks like it's going down. This line looks like it's going way down. This is a level line. It's how our eyes work. It's how perspective works. And that's how we see the sun go away. Now, other times, you can be on a super clear day, and I filmed this on the East Coast, filming west during sunset. I had my drone up, below freezing, no humidity, no clouds, no nothing. And the sun in 5 minutes, it went down, 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 down. And it would just keep going if we were spinning, but it didn't. It went down, 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 and it stopped. And it sat here for 10 minutes. Now, my friends at the beach saw a normal sunset from the bottom up, but I'm watching this thing. It stopped going down, and it just disappeared into the thickness of the atmosphere. Okay? into the thick. Now, you've never seen a sunset like that. That's because you're not looking through a 4K camera. You haven't gone and post zoom.
Well, how do you know I've never seen a sunset like that?
Well,
you're assuming. I've been
assuming.
I've watched hundreds of sunsets on the ocean.
Yeah. But this can only be filmed from a high altitude and a super clear day. And also, it could be filmed like this soldier filmed this in Afghanistan. Super clear, super dry because of no humidity, because the humidity will block the sun. And the sun just kind of sits there and it gets smaller and smaller until it kind of fades away. Might be going behind.
Yeah, but hold on. There's a lot of problems wrong with what you just said. That you said there's no humidity. There's no relative humidity right there in that area. But what you're looking at, you're actually looking at about a 3 to 3.5 mile horizon. Plus, you're looking at a sun that's supposedly 92 million miles away, which means that you have not only the relative humidity, the barometric pressure, the atmospheric dispersion at that level. You also have it at the edge of the Earth, if it's a globe Earth, of all the way to that counteractive part of space through the sky. So there is moisture in that area right there. We can't assume that there's not, unless person
you can't.
Right, there's no controlled experiment that actually showed there was no moisture right there.
On super clear, super dry days, and that's why I can only do my sun fade out when it's below freezing, because then there's less humidity.
I understand that. So few things. So I've seen a green flash. Do you know what a green flash is?
Yeah, I've seen that. That I don't think that has anything to do with the shape of the Earth.
It has everything to do with it, because actually what's happening here is if we're talking about a flat Earth and the sun is just moving parallel like this or perpendicular to the Earth like this and just kept on going, there would be at no point would we see a green flash, because it's actually the angle of incident of the sun going around the horizon on a curved Earth that produces that green flash. I've seen 3 green flashes on sunsets on the ocean. Now that happens at an angle, I think it's about 37 degrees of when the sun sets over the horizon, and the atmospheric dispersion, the amount of pressure, so forth, and moisture in the atmosphere is just right at the edge of that ocean to produce a green flash. Now that can only happen if the sun is at an angle relative to that horizon.
That's why I say cool story, because on a flat Earth, as it's going away, it's going behind an opaque barrier. Now, when you say it's going behind the horizon, what do you call the horizon? Is this a horizon right here? Like if this was if this wall was
horizon would be visual spectrum of the horizon would be the visual limitation of our vision, of our actual relative vision, of our perspective.
Okay, so you're saying the horizon isn't the curve of the Earth; it's just the limit of perspective.
Well, it depends, because the curve of the Earth changes. On the ocean, you're looking at about 3.1 miles, where on the surface you could be talking a lot more. And so I guess the good question here is how do we measure that curvature of the Earth? And that was one of the questions I had when we started on this part here.
Right. So that's a great question. You need R for that. You need the radius of the Earth for all of this stuff, and no one knows how anyone got the radius. No one knows how the radius was derived, right? But here's the thing. If with a radius of 3,980 miles or whatever it is, it's just under 4,000 miles, a 6-foot tall person standing at the edge of a calm ocean, their physical horizon should be 3 miles away. So if this is the physical horizon, I'll flip this over. This would be my physical horizon. And if I walked over that and disappeared beyond it, you couldn't zoom in and see me because you have a horizon. I'm below the horizon, and once I'm below it, you can't see me. Correct?
Yeah, unless there's certain atmospheric phenomena happening. But yeah, in a perfect world, in a controlled experiment, perfect world.
So when you go watch a sunset at the beach, if you're standing at the edge of the water, the maximum distance that horizon should be, if the water's perfectly calm, if there's waves, it'll be even closer, is 3 miles away. You can look and you'll see boats 3, 5, 10 miles away, and you'll see the boats, and the sun will be beyond them. If the Earth is the size 24,901 miles that they tell us, the physical horizon of the ball, because on a ball you have to have a physical horizon, would only be 3 miles away. That sun is not setting behind a line of water 3 miles away, and we can prove this.
It's definitely not. No, it's not. It's following an angular trajectory, right?
It would have to
because of the Earth's rotation around it.
Okay, but that doesn't matter. Forget the rotation of the Earth. You're standing on the Earth, and you draw a line from your eyes to where it come tangent with the ball, and that would be 3 miles away, maximum of 3 miles away. And then you look at the sun The sun isn't going behind a line 3 miles away. It's not. Like here, you can't see this boat, but there's a boat here.
No. The sun is not. That's the thing. Is you have to take that imaginary line and put it out into space 92 million miles. You'd be looking at the sun, correct? Where your limitation of your actual horizon is 3 miles. So there's two variations of distance that we're actually looking at here, right? So when we're looking at this,
you're not understanding. You're not understanding.
Oh, I'm understanding.
So I'm on a ball, and the sun is going to set like this as it goes around the ball. Okay. It's going to set. This line that's cutting off the sun has to be 3 miles away from me. This line
it varies,
that I'm looking,
but yeah.
No. It doesn't. The Earth. So the Earth is lumpy now. I'm talking about over calm water.
Yeah.
They tell us the Earth is a sphere, right? That edge that blocks the sun, right? That you have to believe that you're falling over backwards faster than the speed sound.
Yeah, hold on. Let's reiterate what I said there. You're talking about a 6 foot man standing on the surface looking out. That's going to be 3 miles. That's where variability comes in with the distance of elevation.
Yeah. How about a person sitting down? The sun should be setting like 1.5 miles away. Okay. Yeah. That's not what we see. We don't see this horizon is apparent. Watch, this horizon will change as I zoom out. As I zoom out, that boat will disappear from the bottom up just due to the wave front edge because of the angular size and a glober. The actual, if you knew the distance of this boat, it should be hidden behind the curve, but we're able to zoom in on it, increase its angular size, and see it.
Yeah.
So let's back up a little bit. You know how fast the Earth is spinning in the heliocentric model?
How fast the Earth is spinning around the sun? What is it, about 300,000?
No. The rim speed of the Earth's rotation at the equator.
Yeah. So it depends. Are we talking about angular velocity or are we talking about linear velocity?
I'm talking about linear velocity.
It doesn't have a linear velocity. We can't measure it in linear velocity. It absolutely does not. It can't. It's impossible. You're talking about a rotational body that is incredibly large. If I sat there and I did the comparison, proportionality of a baseball to the Earth spinning at 1,000 miles per hour around its center in the linear velocity, we'd be looking at it's like, what, 0.3 revolutions per minute? It's negligible. So baseball would be sitting here going millimeters at a time for 24 hours if we did the proportionality of this. Well, there is a difference between angular velocity and linear velocity in the sense of when we're looking at this. And when we look at meters per second or meters per second squared in the sense of velocity, we have to take that into context.
Well, what you don't understand is the Earth is just over 24,000 miles around. Yes. It spins around once per day, so you're traveling at 1,000 miles per hour. That's there's no arguing that.
No, miles per hour is proportional. So it's proportional to linear velocity.
Hang on.
It is, but it isn't. So you have to look at it in the sense of the actual size of the object, right?
I absolutely just
Go ahead.
You can't deny that the Earth. If you were in a point in space and the Earth is spinning next to you, and you were right next to the equator, that equator is moving by you at 1,000 miles an hour.
Okay. Yeah.
Okay, that's a fact. There's no questioning that. Okay, I mean that's not. That's not
the equator's not moving. But here's the thing.
It's a globe Earth claim.
Well, but the problem with that would be is you would have to be a stationary reference frame in order for that to be true. And if you're a stationary reference frame, you'd be falling into the Earth, and so you'd actually get caught by the gravitational field of the Earth. And so if we were a stationary reference frame not induced by the gravity of the Earth, yes, the Earth would fly by us at 1,000 miles per hour.
I'm just trying to get to set the stage to show you the speeds and that the Earth is going. The Earth is spinning at the equator at 1,000 miles an hour.
Okay, we'll just accept that, but we have to. I just wanted to make sure everybody knew the difference.
The Earth is 24,000 miles around, and if you rotated it once, it goes 24,000 miles in 24 hours.
Yep,
1,000 miles per hour.
Okay.
Okay.
It's a good visual, but it's different in the sense of how we calculate it in physics.
Well, how do you calculate in physics? A 24,000 mile an hour ball rotating once per day. So a point on that ball is traveling 24,000 miles in 24 hours.
And like I said,
if we took 1,000 miles per hour.
And if we took the proportionality of that ball and we brought it down to, let's say, this thing right here, like a globe, right? Okay. that actual velocity
that's
relative to
moving
me.
at an inch per hour. If that was 24 inches
There
per
you
hour,
go. So it'd be an inch per
moving
hour.
at an inch per hour. Okay.
So
what?
So there we go. An inch per hour. Perfect. No, that's all I wanted.
If you rotated that globe once a day, it's moving at an inch per hour at the equator. Well, guess what? We don't live on a globe. We live on this 24,000 mile an hour ball, so we're traveling 1,000 miles per hour.
Okay.
In a circular. Now it's not in a linear path. It's a curve. So when you curve, that's acceleration. You can be driving 100 miles an hour in a car, but when you start turning, that's acceleration, even if you don't change speed.
There's difference between. We got an audience, so I want to help them out. There's a difference between velocity and acceleration. Acceleration is a continuous change in velocity, where velocity is consistent. Sorry, Dave. Go ahead.
What about when you're going 100 miles an hour and you turn? Does that count as acceleration?
There's angular velocity there, but yes, there's momentum, there's inertia, there's many different planes. So, but go ahead.
Okay, so we're orbiting the sun at 66,600 miles an hour, according to the Satanists that tell us. Okay, 66,600 miles an hour, and we're chasing the sun at somewhere around 500,000 miles per hour. All right. So most people have no idea what these speeds are. So let's take a look. This is a hypersonic sled. You can Google this yourself and watch the videos of it. And it's going by a Mach 8.6. Watch it again. Okay. The sound, it's insane what this thing sounds like.
It's pretty cool.
You have to believe that we live on a ball that is orbiting the sun. Forget the spin of the Earth, okay, at 1,000 miles an hour, faster than the speed of sound. It's going 10 times faster than that around the sun. And we have lakes that look like this. It's chasing the sun at over 90 times that speed. And all of these things are not straight lines. They're current turns. So there's constant change. If you're in a car on a perfectly smooth road, driving straight at 100 miles an hour, best car, best shocks, everything, and you have a dinner plate filled with water, and that car speeds up or slows down just like the Earth does, or takes a turn like the Earth is constantly doing, that water would slosh all over the place. But we have lakes that look like this. We have lakes that are perfectly still.
Well,
and you can say gravity. Don't say gravity because you don't even
we
know
can get
what
into
gravity
it.
is.
Well, I have my theories upon what gravity is, but
so does Neil.
Yeah, well, I've met Neil, but anyways, we can go back and let's just back up here a second. So basically what you're trying to say is that the Earth is spinning around the sun at incredibly fast velocity, right?
That's what they're telling us, yes.
Right, that's what it's about. I think it's about 300,000 miles per hour is at the sun, and you call that the Earth is chasing the sun,
well,
right?
the sun's moving at about 500,000 miles an hour, and all of the planets are magically keeping up with it. So sure, it's chasing it.
Well,
or being dragged along, or being pulled along, or just going with it because it has that crazy speed.
So
this is what
let's establish.
Believe.
Well, let's establish the current theory, the current scientific theory, right? Because what we want to do is we want to be able to have everybody out there draw their own opinion upon this, right? And so we have to show both sides. We have to show people what's actually happening in that model behind your head. And our current science model says is that the sun has a massive gravitational force. This is the distortion of space-time. I doubt that, highly doubt that, but it's a distortion of space-time, and what happens is the planets basically get stuck within this gravitational well, and they are actually moving towards the sun at that velocity in a centripetal form, or in circular form, as the sun's moving around the galaxy doing the same base model. So in actuality, our scientific model explains that it's not chasing the sun, it's actually being dragged along by the sun, and it's, in a sense, locked gravitationally with the sun, and this is why we have all these forces that are inherent, that balance each other out, that counteract each other, and as a real scientist would say, the reason why the lakes don't fly off the Earth and everything like that is because we don't have an absolute reference range. We have a relative reference range.
All right. So as you said in the beginning, unless you can prove this stuff yourself, you're just reciting stuff that is not when I hear this.
Well, isn't that what you're doing?
I go, cool story, bro.
Yeah.
I'm trying to explain to you your model. And you're saying, well, the gravity of the sun is pulling it.
No. I said that was a current scientific perspective. Did I not, Jay?
Right.
I said that was a current scientific perspective.
Right.
Yeah, you're not saying that's the truth.
I didn't say that was the truth, Dave. I said we have to establish the current scientific model.
No problem.
Neil deGrasse.
Okay. All right. No problem. My bad.
Okay. Yeah. So go ahead and you can try to now go ahead and explain your perspective.
My perspective is that we're not moving. So
Okay.
So in the heliocentric model, the story is once upon a time there was nothing. It exploded, became everything, and then all of the rocky bits started sticking to each other and pulling in other rocky bits, and all of the gases started sticking to each other and turned into big giant burning balls that have more gravity, and they left a vacuum which has never been seen in nature ever in between. So now we have burning balls of gas in a vacuum. Now let's take our little solar system. We have our big sun, burning ball of gas that's holding on to Mercury and the Earth and Saturn and Mars, and it's holding on to all of these distant rocks. And somehow those rocks are that we call planets. They're holding on to their own moons, and the sun ignores the moon because, like, for example, here's our moon, and this is not to scale, of course, and our moon is going around the Earth, right? How come when it heads back towards the sun, it doesn't speed up and slow down when it goes pulled away? How come the sun's gravity ignores the moon? How come it could hold on to the Earth, it could hold on to Jupiter, it could hold on to Pluto, but it can't hold on to any of the moons, right?
So hold on. What you're saying is that
here's the thing. Go ahead.
Can I interrupt you?
Go ahead.
What you're saying is that when the moon is between Earth and the sun, the sun should be pulling the moon away from Earth.
When the moon is coming towards the sun, it should speed up and slow down, right? Speed up and slow down, right?
Wait, hold on. Does the moon have an elliptical orbit around the Earth?
That's what they say.
I think it's an ellipse. It's not elliptical in that context. I don't think it's the moon. So
let me finish.
Go on and finish. Jay got me. So, I was kind of going.
So there's a thing called the three-body. There's a thing called the three-body problem. You can take the world's best supercomputer and you say, all right, I got a sun, it's got this much gravity, I got a little Earth, and I'm going to put it around it, and here are the orbits, and here's how the gravity works. It works perfectly. You can predict where it's going to be tomorrow, 10 years, 50 years, 100 years, and it works perfectly. You can speed it up. You know exactly where it's going to be in 1 billion years from now. Then you add a third body, another planet going around the sun or a moon going around the Earth, and the entire model goes into chaos mode, and no computer in the world could figure out what it's going to do next. But somehow, in our solar system, we have all of these planets and all of these moons doing this thing that repeats every year. Somehow, in our beehive, insane galaxy, where stars and planets are moving in all different directions. Hold on, let me finish my point.
I said I liked it.
If you go out tonight and look at the stars and make a little chart, then next year, same night, same time, or in 10 years, same night, same time, every star will be in the exact same position. Then we have eclipses.
He's right.
They tell us that the sun is 400 times bigger than the moon, but it's also 400 times farther. So they happen to be the same size. Okay, the chances of that are 0, but or maybe not 0. Maybe it's 1. Maybe it's 1 in 1 billion. And then the chances of them actually lining up for a total solar eclipse, that's 1 in a I can't even pronounce the number because I don't even know what it is, right? But here's the problem. That's if it happened once. Okay. It happens every year, and then every 18 years, do you know that all of the eclipse cycles repeat? Now, does that sound like a beehive or a clock? A finely made mechanism. It's not a beehive, right? Eclipses repeat every 18 years. Okay. That's
hold on.
In a heliocentric model.
Well, let me ask you this. So I'm no stranger to the conspiracy. The moon is an interesting character. We can go back.
Strangest one of all.
It is, and I was sitting in CU Boulder in a advanced cosmology class, and we were sitting there talking about the origins of the moon. And they told me 3.2 billion years ago, another planet collided with our planet when it was molten lava. And I immediately raised my hand and I said, I call bullshit. I'm sorry, but the statistical probability of an ant smacking into a molecule on a football field 3.2 billion years ago is astronomical. And secondly, if that was the case, why is there no, because they talk about how the moon has samplings of helium-3 and it has isotopic properties of the Earth, but it doesn't have any isotopic properties of this secondary planet, which would have crashed into it, but they found those on the Earth. And I said, well, that doesn't make any sense. I think you need to go back to the drawing board. If we start looking at history, we start looking at mythology, we can see other types of contexts that bring about that our moon most likely is not real. or was put here by something, and that is not a real type of satellite naturally occurring to our planet. If that's the case, okay, or
it's not even a physical object.
Okay, or it's not a physical object. But either way, okay, so hold on, is in that context, right? I'm in agreement that there's some problems with the moon. I'm not saying there's problems with the physics of the moon. I understand the physics of the moon. I don't want to get into an argument about that, right? But I understand what you're saying. Is it seems like this is like designed instead of by happenstance. And I believe that you're 100% correct on that statement right there. Okay? Now, what the moon is, did we ever go there? That's a completely different question. I don't think we did. I think that a lot of NASA is fake. But the fakeness of the moon and the fakeness of the moon landing in NASA does not substantiate that we live on a flat Earth.
True.
Okay.
But maybe this does. You know about the Go Fast rocket? This was a rocket, an amateur rocket launched in Arizona. It went up 73 miles, and then it's questionable about what happened. It was going, it's spinning, and all of a sudden it went kerplunk, like it went into like a thicker medium, not quite water, but it seemed like a thicker plasma. Then all of a sudden it's kind of just floating weird, right? That's not that's super interesting, but that's not the part I want to show you. The rocket turned on its side, and coming up over here, you'll see the horizon, and all of a sudden you'll see the moon. There's the moon. That's the moon. Okay, right? Okay, so there's the moon off in the distance. The moon at that time was over New Zealand. So the Earth is a basketball, and you put Arizona at the top. That rocket was a 1/2 millimeter above the basketball, and New Zealand is underneath the basketball. How did we see the moon? The only way that could be is if the Earth is flat.
Well, no, not necessarily. Is we have to take into account linear and angular perspectives here. So if the moon is 400,000 miles away from the Earth, right, and New Zealand is down here, the moon can still be underneath New Zealand, and I can look at it from this perspective right here. Absolutely, 100%.
Yeah, but you're a millimeter, the Earth, at the size of the Earth they tell us, and the height that it went, you can see sideways, right? You can see sideways. New Zealand is down here, right? This is the horizon. And it's funny how the horizon...
Well, I don't know. I mean, I don't know this launch. I don't know the details about it.
Oh, all right.
I could say I can take your word for it, but I'm not going to because I don't know,
don't.
right? But that's the thing is if we're looking at that moon from that distance, 400,000 miles away with no atmospheric magnification, right? What would that look like? And I mean, it would be an experiment it would actually just be calculating the blah, 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 the angles there and just looking at that and see how that could actually happen, right?
Once you look at it, and a lot of people have done it, you got to do it yourself. I'm just pointing these things out to
Correct.
you. At the beginning, Jason was mentioning some flight routes. Let me show you a couple flight routes and some emergency landings and some things, and then you can think about them yourself, all right?
Yeah.
And you can go verify it yourself. Here's Hawaii to New York, and they had an emergency landing in Seattle, which is close to 1,000 miles off this flight path. This is the flight path they said. But if you look at it on a flat Earth, Seattle is right on that flight path. Here's another one. Okay.
Well, hold on. What point in the flight did they have an emergency landing?
The emergency landing was somewhere in the middle. Not sure. Somewhere out here.
Well, even on a globe Earth. I mean, even on a globe Earth, if we looked at this, if I was going from New York to Hawaii,
here's the globe right here. Here's the globe right here.
Well, no, I got a globe right here. That's a 2-dimensional globe. This is a 3-dimensional globe. If I'm going to Hawaii,
we can't see it.
Yeah, we can't see it.
Oh, you can't see it. So if I'm going from New York to Hawaii over here, then Seattle would be a very good logical point. And this obviously this isn't real because this isn't the scale, but Seattle would actually be probably the point you would want to in the middle of the flight to go to for an emergency lander. It would either be Seattle or LA. And probably in that example, they probably picked one of them and had whatever one had landing. I worked for an airline for 6 years. So whatever one had, the runways open, the airport open, probably the cheapest landing fee, so forth.
Yeah, I got it. So how about this? This is from Auckland to Pima to Peru to Lima, Peru.
Yeah,
Lima, Peru, and it stops in Los Angeles. Okay, now on a globe, that's kind of crazy that it goes from the southern hemisphere into the northern hemisphere and then back to the southern hemisphere. But this is what it looks like on a flat Earth. Let's look at this. That's
odd. I've never seen that flight before.
Yeah. So here is one from that stops in Amsterdam. From It's going from Buenos Aires to Johannesburg, goes all the way up to Amsterdam, which is crazy. Now, check this out. Southern Flight, whatever this latitude is here. Do
you have the flight logs for these?
Yeah, I'll show you where they all are.
Oh, cool.
Okay. And so this is about 5,000 miles across. Well, this is a way, way longer trip. But here's the thing. This red line is the equator. And so we have southern flights that constantly cross the equator and then cross it again and go to their destination, even direct flights. So now let's look at this one from Santiago to Australia on a flat map. It's a straight line. But so again, southern, cross the equator into the north, cross the equator back into the south. Now, why don't we ever see a flight that's in the north? So let's say, I don't know, let's say this is 50 degrees south and 50 degrees south. Both of these are 50 degrees south. I'm just making it up. And so we'll find something 50 degrees north, another one 50 degrees north. Never, ever do any 2 points in this northern circle cross the equator to get to each other. You can stick a pin anywhere in any of these inner northern countries and check the flight routes. Never, ever do they cross the equator. But then you have...
Well, they wouldn't have to on a globe Earth either. On a
Correct.
globe Earth, they wouldn't have to.
Correct. Doesn't prove the Earth is flat. Why do the southern ones do it? Because
I don't know that. I've never looked too much into it, so I don't even know that that's true. Right?
So I'm going to show you where to find all of this information.
Okay.
So on a globe Earth, seasons should be equal at equal latitudes, north and south. Seasons, daylight, flight routes should be the same. Seasons 6 months apart, but the flight routes should be the same. If this has to go into the north, then it should be the other way around also, if the Earth is a globe. So there's this book. You can get it free online, or you can buy the book on lulu.com, 16 Emergency Landings, Proving Flat Earth. It has all of the details of what happens on these flights, where they landed.
Well, can you give me one reference to actually one of the ones you just talked about that I can look up on a airline's website and actually see it, or on a flight data website where I can actually prove that that's what happened?
Yeah. Well, it's all documented in this.
I don't want to buy a book. I'm asking if you have that right now.
You can download the book free online. Just download the book. It has it all there. So here's one. They were going from Taiwan to LA. They were right near Hawaii when they had an emergency. Instead of landing in Hawaii, they landed in Alaska.
Okay. That happens, though.
Yeah, and the reason that happens is Taiwan, emergency, Alaska. Hawaii is all the way out here, right? That's how it goes. That's why the Alaska is a huge shipping hub, because it's the center, right? You want to get any 2 points. A lot of times you have to go across the center. This is where it happened, right? Emergency, they were right out here. They could have landed here. They could have kept going. Instead, they went all the way to Alaska. And this is because all of these landings.
But actually, what you have to look. There's, for that one in particular, what you were looking at is we're looking. The visual perspective of everybody here is looking at a straight line on a two-dimensional map representing a three-dimensional flight pattern, right? And the actual three-dimensional flight pattern is actually like this.
Flat flight pattern. Airplanes don't fly diving over a ball. They don't nose down, right? When you're flying out of a ball, you have to nose down. Let's switch.
Wait, hold on. Why do you have to nose down?
Because the Earth is curving away from you. If you had kept it
so do I have to nose down when I'm walking on the street?
When you're attached to the Earth. If you're flying in the air,
so is the plane. It's a relative reference frame. The plane is moving at the same velocity as the Earth's rotation. Hence why, absolutely. So everything within the Earth is moving in the relative reference frame of the Earth. We were talking about earlier, the 1,000 degree spin, right?
Answer me this question. So at the equator, it's 1,000 degree spin. We determined that. But if you were 1 mile from the North Pole sitting on a runway, how fast are you spinning?
Don't know. Didn't calculate it. But we're just using 1,000 miles as an arbitrary amount because that's what makes sense.
No. This is important. This is what people don't think about. It's moving at 1,000. So if you're sitting on a runway, you're moving at 1,000 miles an hour before the plane even starts rolling.
Correct.
If you're sitting a mile from the North Pole, you're only in 24 hours moving 3.14 miles. So you're moving less than a quarter of a mile an hour. Okay. So you're moving less than a mile an hour. So an airplane takes off from Alaska or from the North Pole, and it flies to Ecuador, and it wants to land on a runway that's oriented north and south. Well, that runway is spinning sideways at 1,000 miles an hour. Where did the plane get that linear speed to go 1,000 miles an hour? And if you say gravity sped it up gradually across the flight, you're just saying words that have no proof.
Why? Okay, well, hold on. Sense. I'm saying words that actually have a mathematical formulation and can validate that theory. Now, let me ask you this: show me within your theoretical model the math that actually proves that, or show me through scientific conjecture the postulate that actually proves your side of the theory. Because I've seen it on the other side that if I leave from Alaska and I'm starting to fly south, right, towards Lima, Peru, or whatever it is there's a gravitational effect happening there. I am gravitationally, if you want to say it like the same thing as walking on the earth. I'm attracted to the earth. Gravitationally, I am attracted to the earth. That's why I don't have to walk nose down trying to fall forward all the time around the earth, right? The same thing with the plane. The plane is locked within. The air is locked within. The clouds are locked within. The atmosphere is locked within the rotational spin of the earth. It's a relative reference frame, right? So when we look at this, that plane takes off. Yes, the gravitational conjunction at that altitude conforms to that velocity. And we can prove this.
Which gravity are we talking about? Which gravity are we talking about?
You know what? If we want to talk about gravity, Einsteinian gravity, Newtonian gravity, we can. I know the theories very well. I disagree with them all. Okay? I disagree with them all. I believe in a completely different theory of gravity. And mine, I've actually proven, I've done theories on it. So, but it's a little bit different, but it works the same way. And so, I mean...
Well, I have a completely different theory on gravity. And the only true forces in this earth are electricity and magnetism, which are brother and sister. They go together. The earth has a negative charge, testable, measurable, negative charge. It does. The sky has a positive charge to it. So anything that has any charge, so there's an electrical flow into the earth. One way to prove this is stick a solar panel outside, and it'll capture the electricity. It's not capturing photons; it's capturing electricity. Okay, so there's a flow like a river, and so that little flow at the Earth's negative charge, it says, hey, down is this way. It's a weak force, just like gravity, right? So we live in this giant battery system. The moon is the anode, the sun is the cathode, the salt water carries the current, the land is the salt bridge, and it's this free energy system, which has been proven. There's free energy all over the place. So down is down. If I had a handful of marbles, ping pong balls, and a helium balloon, and I held them over a pool and I opened my hand, the balloon is going to go up because it's less dense in the air. The marbles and the ping pong balls are going to go down because they're more dense in the air. The ping pong balls will sit on top of the water because they're less dense, and the marbles will sink to the bottom because they're more dense. Relative buoyancy and density sort everything else out. The flow of electricity into the earth is what causes the downward direction. That's it. If I point forward, that's your backwards. My backwards is your forward. My left is your right. Your right is my left. Doesn't matter. It's relative to everybody. But your up is my up. My buddy in Australia, his up is my up. Up is up. Down is down. Period.
Okay, so hold on. You mentioned buoyancy and density. Yes. Okay, these are what? So explain again. So you're saying that gravity is electrical in nature. Okay, how is this electricity created? Let's just start there. Show me how the electricity is created.
The sun is more like a Tesla coil. All right. There's other people, by the way. There's other people that do this research better than me. If you want to check it out, L.C. King. He's modeled the entire Earth battery. Tesla proved that the Earth is filled with electricity. He lit up the world.
I don't doubt that the world is filled with electricity. I don't doubt that. Yeah. We have a ionosphere. We have electrical connotation to the ground. We actually have our literal ground. We have static kind of conduction within the atmosphere. I don't doubt that the Earth is filled with electricity. The question is why? Why? So you. Why? So how? Why and how? Why and how? So if I have electricity created somewhere, what's creating that electricity? It's got to be created somehow.
I don't know. It's coming
well, that's
from
not a
God.
very good theory.
I have no idea. I don't know. Here's the thing. I have a car that drives down the road. It has a catalytic converter. I think if you gave me $100 to point to where the catalytic converter was, or whatever, I couldn't tell you where it was. I don't know how it works, but my car works. I don't know.
So Dave,
stuff.
On that same context, Are you going to go sit there and talk to people about how catalytic converters work and that the car works simply because of the catalytic converter?
Right. So there's experiments that people can do that you can test. All right, is it a negative charge?
Dave, hold on. I want to get this in there because I'm trying to learn here. I'm trying to learn as much as you. I was 10 years in the United States Navy. I got a degree in electrical engineering. I worked on gun missile fire control systems. I worked on radar and communication systems. All these things deal with a curved earth and how telemetry, elevation, and all these various things work. So when I come to this perspective, I have to appeal to it from the scientific inquiry, right? So when I ask about the electrical conduction, if you're saying that gravity is electrical in nature, tell me how that electricity is generated. What produces
I don't know how we can measure it.
Okay.
We can use it. I don't know how it's produced.
So if I look at
the sun is a what's it called, not a generator, a converter, I forget the name of it. There's a lot of people, smart scientists that talk about this stuff. Beyond me, go check out.
I understand. I don't want to check anybody else. I just kind of want. We're just having a conversation here. But so. Yeah. They say that the sun is a fusion or a fission reaction. I disagree. I think the sun is actually electrical in nature. I believe in the electric plasma universe theory of our cosmological universe. Good. Okay. Now, in that same relevance, I do believe that there is an electrical connection between the Earth and the sun. We can see this actually just recently. We had a coronal mass ejection from our sun. 2 days before, we had earthquakes, we had volcanic eruptions, and a day after, we had the same thing. This is something that I postulated about 10 years ago, and it has been validated over and over and over that coronal mass ejections, that the Earth is in constant communication, probably electrically, with the sun. Now, with that being said, all I'm trying to say is if the electromagnetism is what's producing gravity here on a flat Earth, what is producing, right, that electrical conductation to the flat Earth? Because I know that on a globe Earth, okay, it is the rotational mechanism. It is the hydraulic strain onto the core, on the crystalline core, on a nickel, cobalt, iron crystalline core that produces the piezoelectric effect, right? Mechanical strain produces electrical strain, electrical conduction. This is proved by Einstein. This is proved in all of our transistor radios, our crystal radios, so forth, that this is how it happens. This produces the electrical conduction of our Earth, and then the rotational significance keeps that and produces our electromagnetic field and so forth, and this is in conjunction with the sun. So I'm saying that's my model that I know of, that I believe in because I've seen it work, I understand how it works, and I can go test this theory. I'm saying is the theory of yours, so you're saying a flat Earth, non-moving, non-rotating, how is that producing electricity? How is electricity happening here? What's producing it? And if the answer is I don't know, then that's not a very good theory for gravity.
No, there's tons of videos that you can watch. I tell you, LC King, he explains it. I can spend hours, or you can go watch a few of his videos and you go, oh, that's how it's created. This is where we add some negative ions to a negative charge.
We'll agree to disagree on that one.
It's defying gravity or defying electromagnetism. So here's the thing. You believe that we have this magnetic core, the deepest hole ever dug. This may not be the actual
8 miles.
hole.
It was about 8 miles.
Short of 8 miles. That's like halfway through the skin of an apple.
Agreed.
Okay. And while they were doing it, they used ground penetrating radar to see what they're going to hit next. And they were wrong every step on the way. They should have gotten their money back on that equipment, but who knows? So they were wrong every step of the way. Then they hit that impenetrable barrier. They couldn't go with too hot, too hard, whatever the reason is. They couldn't go any farther. But all of a sudden, the liars at NASA and everyone else say, oh, we know what the next 4,000 miles is. Okay.
Agreed. Yeah. Okay.
So,
did you know Nikola Tesla actually measured the radius of the Earth to the core? And he did that at Wardenclyffe with extremely low frequencies, ELFs. And so the way Wardenclyffe actually operated is he had to know the electrical frequency, the conductive frequency of Earth. And this is a 7.83 hertz known as the Schumann resonance. And this is how he was actually able to transfer electricity to the ionosphere. Now, what people don't realize about the Schumann resonance is it's only a half a wavelength, or about a quarter of a wavelength from the surface to the ionosphere. The rest of it actually goes to the center of the Earth. How we measure that full wavelength is from the center of the Earth to the edge of the ionosphere. That's how we actually come up with the 7.83 hertz. So he actually measured the radius of the Earth dependent upon that actual calculation of 7.83 hertz.
Yeah, that's a bunch of math, and we don't live on a math equation. And
well, that was Nikola Tesla. That was Nikola Tesla.
But Nikola Tesla said a lot of things. I wasn't there.
Plus, there's many other scientists that Schumann,
I have
Professor
a
Schumann,
dollar's
actually.
worth of change. I have $1 worth of change in my pocket, and it's 4 quarters. Okay, is there any other way that I could have $1 worth of change in my pocket? Right? It's not necessarily 4 quarters. You can explain things a lot of ways. For example, Aristophanes said, "Hey, I got no shadow here. My buddy 500 miles away, he's got a shadow." He does some math, and as Carl Sagan and Neil deGrasse Tyson have drilled in everyone's head, that math perfectly proves the size of the Earth within like 2%. Okay,
the Egyptians did the same thing.
Yeah, well,
between it was between Cairo and Abydos, and they actually measured that with the obelisk that they had there.
Yeah, and that's because the sun rays come in parallel, right?
Mm-hmm.
Right? Have you ever seen parallel sun rays? Whether they're refracted or not, you've never seen parallel sun rays. Okay, and so they say, well, the only way we're brainwashed into believing that the only way that this can happen is with a distant sun that with parallel rays coming in and being on a ball. Unlike in the flat Earth model where we have a small local sun, over here, his buddy 500 miles away, you take these angles, do the same math, and it'll prove the sphericity of this flat surface. Okay? There's more than one answer for things. Right?
Well, there's more than one answer for that one, but obviously the last one, it was a hard one. But
this one doesn't prove that the Earth is a ball or flat.
Neither one
proves that.
But I can go outside right now at high noon, which would mean that the sun rays are coming in perpendicular to the Earth's surface, which would be parallel in the context of the two-dimensional model, right? And I can measure it here one day in Thornton, Colorado, right? And then I can measure it at 3 p.m. And then I can go 50 miles away or 500 miles away. I can measure it at noon, right? And 3 p.m., right? And I can take that, I can take that distance, right? The angle, and I can subtract them from each other, and it would give me some number. And that number would be different if, right, we're on a globe Earth.
False. So if you take, just put up a couple beer bottles. I'm going to false. Put a couple beer bottles on the floor. Hang a light directly over one of them. So I'm hanging a light directly over this one, and there's no shadow. And then over here, there's a shadow, right? And then if I move the light from here over to here, well, now the shadow's over here. If I put another beer bottle over here, it would have a different shadow, okay? And that's exactly how it works in a flat Earth, but everyone's wrapping that around a ball.
Okay, so how does the sun move around the flat Earth? Can you show me this?
All right.
Maybe that's the context that we're not seeing here.
Yes, I will show you.
All right, I appreciate that.
I'm going to share my screen. You ready?
Go ahead. Let's do it.
What is going on here? All right. See that? All right, this is my app, the Flat Earth Sun, Moon, and Zodiac Clock app. The way it works is the sun and the moon that we see are small and local above the Earth. The sun is close, and wherever the sun is, it's noon. Now, we don't see the sun in its actual position. That's a whole nother thing. Maybe we have time to get into that later. But like right now, it's noon in Central Africa, right? The sun is rising on the East Coast in the United States, right? So the sun goes around, keeps track of the hours and the days. Let me speed it up. And the sun will lap the moon once every 28 days. So the moon and its position and phase keep track of the weeks and the months. There used to be 13 months of 28 days, but they hijacked our calendar. Go ahead.
Dave, few things here. Number one thing I'm going to say, can you stop it for real quick and let's kind of look at this in a... Okay. The sun is in the middle, and there's this arbitrary line that goes to the middle of that circle that just cuts off all the light. What's stopping that light from going over to the other half of the circle? Because it obviously extends to the left side. If I look at it from this side, it extends to the left side, but it doesn't go to the right. It just kind of arbitrarily stops. What's stopping that?
So go into the atmosphere is one, but go into a nice big dark room.
Well, so that would say that the atmosphere is variable.
Let me answer the question. Okay. The atmosphere is only part of it. Like on a foggy day, an unclear day, it gets darker sooner, but not much. You know, it's still sunset, but it'll get darker just a little bit sooner. So get a big table and hold a light close to the table, and it'll only light up part of that table. The rest of the table will be in the darkness. Now expand that across a big Earth where you have a sun that is, the light's going through all the atmosphere. The atmosphere becomes opaque. And so there's a difference between sunlight and daylight. And then I can show you when I get out of the app, I'll show you how it changes See, right now it's close to almost half and half, but it's wrapping a little farther. The sun's wrapping a little farther around.
Right. But hold on. So
yeah,
we have to understand. So is the light coming from the sun, the ball sun?
Yes.
Is it? Hold on. Is the light coming from that sun? The sun, is that consistent? Is it all consistent all the way around? Yes or no? No. So one side is going to have more light coming out of it than the back side's going to have less light coming out of it?
No. The sun, we're down below. The sun is a source of light, but the sunlight is the direct sunlight.
Well, the reason I'm asking is...
Hold on. Let me answer the question. Daylight is a different thing. So when you go out early in the morning before the sun rises, well, you can read the newspaper outside. Where's that light coming from if it's below the physical curve? And the answer is it's fluorescing the sky. The electric sun is fluorescing the gases in the sky, possibly lighting up the dome. Most of the gas in the high up in the sky is nitrogen. Nitrogen fluoresces blue.
Okay.
Coincidence? I don't know.
Okay, well, hold on a second. So if I'm looking at that sun, that thing right there pointing at the 10 right in the middle, okay, I talked about the arbitrary line that just kind of cuts off light. But if you look behind it towards the 5, it extends past it. If you look towards the 4, it extends all the way up to the 4 and then just stops right there. So, I'm looking at this model and it just really doesn't make sense. And Rich Flat, no, I'm not a fucking idiot. Dude, I think you might have some problems there saying that I'm a fucking idiot, because what I'm doing here is I'm actually questioning, like he's questioning the globe Earth, I'm questioning the flat Earth. What is wrong with questioning things? Right?
Let me. I jumped out of the app because I got to show you how light works on a ball. If I could just find the video.
No worries. And that's what I'm trying to say is we had light extended this way, light extending this way, light extending this way, and it was not even. And what I'm trying to say is if we looked at the light there and the light here, it wasn't even. And that's why I had to ask that, because
now watch. Here we go.
Mm-hmm.
So I believe that there's a dome, whether it's an atmospheric dome, a physical dome, whatever it is, I believe that there's a dome. So here's a glass dome, and we're just moving this light ever so slightly towards the center. We're basically in between the tropics. And as you see, when I move it out, the light wraps around farther. So you have more dark, and then you have more light. And this is time and date on an AE map, and it does the same thing. Okay, the sun will so right now the sun is in over the Tropic of Cancer, and now I'm going to move it out over the Tropic of Capricorn. And look, the light is all the way over here because it's wrapping around the dome just like it is here. That's why people say in Antarctica there's 24 hours of sunlight. No, there is not. There's 24 hours of daylight, right? Because it's fluorescing the sky, and so this is what we can match. Now, if the Earth was a globe, any time of the year, no matter what, half the Earth would be lit and half the Earth would be in dark. Okay, period. Some areas may be lit all the time because of the tilt and spin, but that's not what we have. There's more areas of the lit that are lit at different times of the year, right? During our summer, the smaller area of the world is lit. And so let me go back into the app, and because I know the next question that you're going to ask is if the sun is going out over the Tropic of Capricorn. Where'd it go? Is this it? There we go.
Yeah.
So it should be going faster, right? Because here, the angular speed is the same, but the linear speed is much. This is a smaller circle. This is the Tropic of Cancer, and this outer one is the Tropic of Capricorn, right? Mm-hmm. So it would have to be going faster, right? When the sun's out here, it would have to be going faster, correct?
Yeah, makes sense.
Okay, so let me quickly show you seasons. And before I show you, let's do a quick thought experiment. What state are you located in?
Colorado.
Where are you? You're in Colorado, so it gets cold in Colorado. So imagine you and I are up on top of the mountain in the middle of the winter. Mm-hmm. It's freaking cold, and we're sitting 20 feet apart from each other. Okay.
Okay.
And then somebody comes over and the big pole holds a heat lamp 10 feet over your head. Big heat lamp. You can feel that heat coming down on you. That's your summer sun. Okay. I'm 20 feet away. That sun is lower in the sky for me. It's down low. It's far away. I can't feel it. Now, keeping it at 10 feet, they move it over to me. You watch that thing go lower in the sky. I watch it rise up, and now it's over me. I can feel the heat. You can't feel the heat. So let's look at the seasons right here. Let me.
So you're trying to explain the seasons. So everybody knows you're trying to explain the seasons. Go ahead.
Correct. So the outer southern lands have their summer while we have our winter. This is the same thing. So right now, this red line is the equator, and the sun you see is right on the outside of the equator because it's moving out towards the Tropic of Capricorn. So let me jump it forward to December. So on December, it's over the Tropic of Capricorn, and Central America is having their summer because it's super hot. Okay, the Australia is having their summer because the sun will go right over them. I'm up here. You're up here. It's cold because the sun is far away, and because it's far away, it's lower in the sky. We have shorter days because it's farther away already.
Right, but we're looking at a 24-hour chart of the sun. We're not looking at a 365-day chart of the sun, right?
I'm showing you this is 24 hours, so the sun never comes close to us because it's far away. It's circling. It's far away. When something's far away, it's lower in the sky. Look at a street light above you and a street light down the road. The street light above you is your summer street light, and the one down the road is your winter street light.
Okay, but so hold on. So the seasons are represented by aphelion, periphelion, right? The distance, obviously the distance, but the rotation of the Earth, the 23-degree rotation of the Earth. This is how science perceives it, right? Is our Earth is angled, and that angle is switching depending on aphelion or periphelion. Okay, so when we look at it like this, the sun is going to rise in different spots every day. We can see this through the precessional cycles. We can see that the sun increases from December 21st, 1 degree in the sky every day. It does this till June 21st, the summer solstice, where the sun stands still. That's what the word solstice means. And it begins its fall 1 degree each day. And then it stands still for 3 days starting on December 21st to December 24th, and starts its rise again on December 25th. Now, with that being said, is each day noon gets lower or higher in the sky depending upon the season. I'm not seeing that represented on this.
Well, you're not so let me finish.
Yep.
As the sun moves away, it gets lower in the sky. As it moves back in, it gets higher in the sky as it moves closer to you, and the opposite for people in the south. Okay? So I'll move it in 6 months. 1, 2, 3, 4, 5, 6. 6 months, it's over the Tropic of Cancer, and that's why it's friggin' hot in Miami and in Mexico, because the sun is directly over their heads. So on June 21st, if you're in Miami at noon, the sun will be directly over your head. For me in Connecticut, it'll be warm because it's pretty close, right? But somebody in Australia, it's far away. It's far away.
So does the velocity of the sun
changes?
It changes, explain. So it's variable.
Yeah. Yeah. So again, what changes the velocity of the sun? I think the sun that we see is a projection, just like I was showing you that light outside of the dome. So if you were standing on the floor, and you're holding a flashlight, pointing it 3 feet out in front of you, and you spun around as a rotation speed of 1 minute per rotation, you just drew a circle with that light with a 3 foot radius. Okay, 3 foot radius. Right now, if I point the flashlight 6 feet out and I do the same rotational spin, I just drew at the same rotational spin. I just do a 6 foot radius, a circle twice as big. So that's how the sun speeds up. Now, what evidence is there that the sun speeds up? Here in Connecticut in June, when the sun sets, and probably in Denver too, how long is it still light out? It's still light for like 90 minutes, almost 2 hours in the summer, right?
Yeah, let's go back to this. People are they want to hear us talk and how we explain. So so you're saying that I want to encapsulate the theory. Okay. We got to encapsulate the theory to take it in, right? We want the best information possible to use our own discernment. So what Dave is saying, and Dave, correct me if I'm wrong, is that the sun moves on this outwardly circle, right? And then what happens is it starts to move in when your season changes relative to your position on the flat Earth, and that the sun's velocity is variable. And you say it's variable because it's a projection onto the globe. It's outside of the globe, and it's a projection on the globe.
It's a projection into the globe, into our dome, and we see it through what I call our personal atmospheric dome. For example, here is a glass dome on top of a blanket. Right, I'm just moving a light across. And it's much better in person. You can do this yourself. It looks like there's a sun inside the dome, and it rises, and then it sets, and then it never goes below the horizon, just like my sun fade out. It just fades away. And then when I bring that back, right, I just change directions rather than going around. You'll see it rise off the horizon, rise over your head, and then it'll set, as it moves away, right? And so we all see within our own personal atmospheric dome, everybody sees the sun and the moon in a position relative to themselves.
Okay.
If I'm driving down the road one way and you're driving down the road the other way, and we're both as little kids looking up at the moon, it's following both of us in two different directions. Okay? That's because we see it relative to our own position.
Mm-hmm.
When you and I are standing at the edge of the water watching the sunset, you see a line going right to your feet, and I see a reflection going right to my feet. I can't see your line. You can't see my line.
Agreed.
Okay. So what evidence is there that it's going faster when it's over Capricorn? Well, in Central Africa in December, when the sun sets, the equal latitude in the north, the sun sets, we have light for another 90 minutes or even longer. In Central Africa and other places in the south, when the sun sets, 5 minutes later, it's pitch black. You can't see your hand in front of your face.
So
and that's because the sun is booking away.
Well, hold on though. Is in the context that you're explaining it, right? The velocity of the sun speeding up or slowing down. Now, in the secondary relationship, if we're talking about a globe Earth, this is the rotation of the Earth around the sun. Now that marks 1 day or 365 days, which means that if it's speeding up and slowing down, that variability would have to be accountable in the calculation of a day. Each day is 24 hours. So where do we see in that variation within the 24-hour time period?
So I have two flashlights in my hand. One of them's my summer sun, and I'm pointing at 3
No. I'm looking at the math. You said.
I'm just telling you. I'm telling you.
I don't need a visual construct. I got the visual construct. I need the math.
Here's the problem. On a ball, equal latitudes north and south, 6 months apart, should have the exact same sunsets, sunrises, everything should be exactly the same. They're not. Life at 60 degrees south should be the same as 60 degrees north, 6 months apart.
No,
it's not.
Oh, 6 months apart. Okay. I see what you're saying.
On a ball, it would have to be. So now on a ball with the sun, going the way we go, we're going around. After December 21st, the sun, the days will get longer for us in the north as we're coming back around, and so it should equally, we gain a 1 minute earlier sunset, 1 minute sunrise, and 1 minute later sunset. That's not what happens on December 21st. The whole thing shifts. Like something is shifting speed. If you go look at the charts of when the sun rises and when the sun sets after the winter solstice, that it changes. Like sunrise will stay at the same time.
Yep. For
like a whole bunch of days in a row, but then the other end will change. What that proves is something is speeding up or slowing down.
Not necessarily. Well, let me ask you this: is it actually sets on the Southern Cross? I can't see the Southern Cross from the Northern Hemisphere. Why not?
Very easy. So let's say you and I are standing in a room, and we have a whole bunch of recessed lights in the room at 10-foot high ceilings, and now we expand that room to 5 miles wide, and I send you 2 or 3 miles down the room. I can't see the lights that are above your head, and you can't see the lights that are above my head because the ceiling and the floor have merged together. We don't even have the atmosphere, that we have, not the atmosphere, the thickness of the air to block it, because we're only talking about a couple miles. I can't see the lights above you. You can't see the lights above me. That's because they're too far from us, period. So here's the thing. On a ball, no one should ever be able to see the North Star from the Southern Hemisphere, but it's been spotted from 30 degrees south. There would be 100 miles of Earth in the way.
Have you spotted it yourself?
I have not, and again,
okay.
Good point.
Well, hold on. I've been to the equator. I've been south of the equator, and we've watched the transition of Polaris as we went north from Washington State, and we went towards the equator, circumnavigating south, okay? Yep. And we watched Polaris disappear.
You didn't circumnavigate. You went south.
Well, no, we went south. And then we went through the Panama Canal, and we came right back up the other side of the East Coast. So we circumnavigated the Northern Hemisphere, the Southern Hemisphere, North and South America.
You didn't
circumnavigate the globe.
You went south, you went north. That's fine.
But so when we look at this, is I've went from Washington State where Polaris is kind of almost dead center, and you start going south, and this starts moving away and away and away and away, and until all of a sudden it goes below the horizon when you get around the equator.
It merges into the horizon.
Well, whatever we're going to call it.
No proof it goes below.
No, we're going to just say that it disappears. And then I see the Southern Cross, and then during the summer months, I can see the constellation of Orion. Now, like right now, in the constellation of Orion is in the winter month, this is coming up just to my east and starts rising. Now, this will come up in the east, and throughout winter, this will move north.
Yeah.
Right? It's rising and setting will start to move.
Let me explain how it does that exactly. So if I turn on the stars here, the stars are going slightly faster than the sun to the point where they don't lap, like the sun laps the moon every 28 days. The stars lap the sun once every 365 days. So right now, this constellation here, which is, was that Virgo or whatever it is.
Yeah.
It's catching up to the sun. The sun will work its way through here. Next month, it'll go into this constellation. The following month, it'll go here. I believe that's Capricorn. And then a year from now, we'll be right back to where we are. So that explains the movement of the stars, which keep track of the seasons and the years. The sky is a perfect clock, okay? The sky is a perfect clock, not
hold on.
heliocentric model.
Let's take that same thought. The sky is a perfect clock. Can the sky be a perfect clock in a globe-centric universe where the Earth is a globe as well?
So remember the.
It's a yes or no, right? It's yes or no.
I'm going to answer.
Okay.
The answer is absolutely not. Remember the three-body problem. They can't model it. And if you think about it, we have all these planetary alignments. All this stuff happens. What about the planetary alignment? Does something tug on something? Won't something be pulled out of place by some gravity somewhere? How is this such a perfect, precise clock, right? In a heliocentric model, there's gravity. There's impossible things. You have high pressure next to no pressure. You have stars burning in a vacuum. You have the sun that can only hold on to planets. It ignores the moons, and everything works perfectly and repeats. I mean, the cycles of the eclipses prove that this is a very well-made, intelligently designed system.
So it could be a simulation, right? It could be a simulation.
Okay, absolutely.
It could be a simulation.
I call it a physical simulation.
I would definitely not rule out the possibility of that we live in a simulation.
Right.
I would not rule out the possibility that, that this was somehow intelligently designed. Okay.
Right.
But when I look at things and when I look at it in my experiences, the things that I know that I've studied that I can prove legitimately through math, through the scientific method, right? Through empirical data, through these types of things, right? I can make an observation. I can ask a question. I can test a hypothesis. I can make a prediction based upon that hypothesis. I can test that prediction, and then I can repeat it, right? I can do this over and over and over again. And I've seen this. I've done this in school. I've done this in high school. I've done this in college. I've done this in the Navy, right? And, I'm not going to say that I didn't have questions, because when I went through basic electrical school in the Navy, I had a lot of questions that didn't make sense to my instructors. They pulled me aside. And they're like, well, you're kind of right. We just teach it this way. And so, yeah, there are major problems with our whole scientific premise today, including the religion of science. I believe science is a religion. I believe that science is leading mankind in the wrong way. I believe that they withhold, hide information from us, that most of our theories today are highly antiquated, probably about 200 years old, and that they hold back technology. I think that partially NASA is fake, because I've launched missiles into space, so I can't say that there's a firmament and everything like that, but I know that there are things that I've seen in the sense of the videos that they've done that were bullshit. The moon landing, a lot of that doesn't make sense. We've seen it was the last Apollo mission where they filmed the module taken off from the surface of the moon. And they're saying, oh, well, that's a camera that was sending that signal back to Earth. Well, then why was it moving with, like that remote signal that they had then? And sorry, the math doesn't add up. As in, that was filmed, most likely, and we probably didn't go to the moon. And you have to ask yourself, well, why? Why does that happen? Why would they lie about things like that? Now, I don't know those answers. But those answers that I just said about those questions I had do not show that the Earth is flat, in my opinion. And I know that you agree with me on that as well, but we have to look at everything.
Here's the thing. There's things can fall into three baskets. Works on both. We came across a lot of those things. Works only on a flat Earth. Well, we can see too far. So if the radius is just under 4,000 miles, as I said, a 6 foot tall person should see the horizon no more than 3 miles away.
How you calculate? But how are we calculating the angular?
The viewer's height times 1.22. I forget the exact number. Just look up globe Earth calculator. Here's the thing.
So the modern science uses a highly incorrect variation to explain the angular distance of the Earth, the angular rotation, or not the angular rotation, but the curvature of the Earth. And I believe it's 8 inches per mile or something. This is highly irregular to even think about it because it's not true. The reason I say it's not.
What's the drop at 10 miles? Do you know?
The drop at 10 miles would be about 100 miles. And the reason that is it's going to be proportional to the square of the distance. And the way you have to look at this is when we look at that 1 mile and 8-inch drop, we were thinking linear mile, 8-inch drop, linear mile, 8-inch drop. But it's not. It's not proportional. It's not per mile. You got to remember that if we're looking at a globe
per mile square, you have to square the mile, and it creates a parabola after 1,000 miles or whatever.
That's
right.
We
don't need 1,000
miles.
We need 10
That's
miles.
A parabolic approximation. We can't use a parabolic approximation in this equation, but we have to look at it, right? We have to look at it in the sense is that if we're going to see this in the sense, right? The Earth is, if we said the Earth is a globe, this means that every millimeter we move is curved in essence, right? So that 8 inches dropped over that curved 1 mile. And so what you find out is it's actually quadratic in its formulation, that the formula for the distance dropped is actually the square of the distance, directly proportional to the square of the distance.
I'm aware there is a drop. We can see things with infrared cameras now that we need a radius of over 250,000 miles. 250,000 miles. If the Earth was a globe, the things that we can see with infrared now, it would need a radius over 250,000 miles, and they tell us the radius is less than 4,000 miles. That's a problem.
Okay? Say that one again. Say that one again. I didn't quite grasp it. You and I talk very fast.
The distances that we can see would require a radius, which is a line from the center of the Earth to the curve of the Earth. If this is the radius, here's the curve. My fingertips are showing the curve. If this is the radius is 4,000 miles, they tell us. Well, we can see things that would require a radius of over 250,000 miles. Okay? So either the Earth is way, way, way bigger than they're telling us, but I don't believe that because large bodies of water at rest lay flat. You can't have a space vacuum.
What are we looking at as 250,000 miles away?
The radius of the Earth would have to be 250,000 miles in order to not be blocked by Earth curve. The things that we're seeing would be blocked by Earth curve on a smaller ball. Like on a basketball, if I move something 6 inches away, I can't see it. It's over the back of the basketball. On an Earth, 6 inches is nothing. Okay? So we can see things that would require the ball to be a radius of over 250,000 miles. The other problem is you don't even need that. I mean, you can disagree with it, but that's a fact.
That's not a fact. It's definitely not a fact. It's not an observable fact or phenomenon.
Does the drop on a basketball drop faster than the drop on a?
I'm not looking at a basketball. I'm looking at a massive 26,000 mile diameter Earth. We're talking about massive size here in the sense of the context of when we're looking at it.
So at 10 miles away, there should be I forget the drop. 10 times 10 is 100 times 800 inches is, what is that? 6 feet or 60 feet?
Yeah, so it's going to be 800. It's going to be 800 inches, which would be divided by 12. What, about 6.7 feet or something like that?
Right. Hold on. 800 divided by 12 equals 66 feet. That's right.
Okay, 66 feet. We're both right.
At 10 miles, there should be a 66-foot drop. Okay. Now, some people like these debunking.
No.
Hold on. Let me finish my point.
But there's no drop. There's no drop. We're not looking at a linear distance. We're looking at a curved distance. There's no drop.
There should be a curve of the.
There should be an arc angle.
If you do a line straight out from my feet, 66, 10 miles away, the Earth's surface would be 66 feet below it.
Okay.
Now, some people say, oh, no, you have to split the difference because the viewer and the thing, and it's only half the distance. That's not true. That's been proven not true. But even if it was, that's a 33-foot drop. We can see things that are only a couple feet tall at those distances. There's no measurable curvature anywhere. Okay, and at those distances, you can't say, "Oh, refraction," all that stuff.
Yeah, you can.
We can see things.
Absolutely,
I can zoom in
you can.
on a boat on a buoy. And it's not there. You're telling me I'm seeing an image of it over the curve.
So Dave, I want to share something with you. So we just drove to Oklahoma from Colorado. We are coming back into the Colorado border. So we welcome to beautiful sunny Colorado, or the sign there, right? And we were talking about getting ready for the show, and I said, well, isn't that interesting? Because when you come in out of Kansas and Colorado, it's completely flat. I mean, it's massive, just flat land. Well, we have something called the Colorado Rockies, right? And I said, well, why can't we see the Colorado Rockies?
Because you can't see forever, and their angular size and the blocking of the atmosphere.
Because the curvature of the Earth begins to drop.
No, because the light off of them can't push to your eyes. The Mount Everest at I forget the distance, is too small to see. It's too small to see. Things get smaller in a distance. Here's my hand. I move it away. It's getting smaller and smaller and smaller. And if I went like a quarter of a mile away, you couldn't see my hand. It's too small to see. That's the same thing with the Rockies. Now, the Rockies are pretty big, but the air will become thick. Like go get a big swimming pool that has perfectly clear water and try to see the other end of the pool underwater. You can't see it.
Hold on. What do you mean the air will become thick? If I'm looking towards my horizon.
It's cumulative. When you're looking across the surface of the Earth, the air is
so you're saying the viscosity of the density, the viscosity increases because of the compensative mechanism of air plus air plus air plus air plus air plus
dust and humidity and pollution and whatever. All of it together, it just becomes opaque over distance. Like on a if you're in a little bit of a fog, you can see your hand in front of your face, but you can't see the person 5 feet from you.
Right.
Okay?
Now I don't know the calculation of how much viscosity of the air density actually increases.
It changes every day.
It does, and it's barometric pressure, that's humidity, relative humidity, all these various things. But that's what I'm trying to say, is if I'm driving down that straight road in Colorado, if I had brought my binoculars, would I have been able to see it? If I brought my telescope, would I have been able to see it?
No.
Because what happened is we started driving about 120 miles out, right? 120 miles out, we begin to see the tips of the Rocky Mountains, and they start getting closer and closer as we start driving towards them. Now, if we look at mathematics and we look at the curve of the Earth, and we understand that the Rocky Mountains, the one tip that I was looking at, was at about a 10,000 foot peak, I should start seeing that at about 120 miles out if the Earth is curved.
So that's what you think, but in
no,
reality,
that's what I calculated.
Well, that you can calculate that, but again, we don't live in a calculation. The thing is, the Earth.
But that's empirical data.
Let me give you some empirical data. Things disappear from the bottom up, not because of Earth curvature. If the Earth was curved, yes, they would disappear from the bottom up. So here's an experiment. We did it in a Home Depot, right? And you can go do this yourself. They have beautiful, long, flat floors, and we could agree that they're flat and that they're smooth. So you get your camera, you get your iPhone camera, and you put it right down on the floor with the lens down low, and you put a red brick right in front of it. Fills the whole lens. Then you drag that brick away. And that brick is going to get smaller and smaller and smaller until its angular size is invisible. You can't see it anymore. Okay. Did it go over the curve? No. It's just too small to see. Now
through the aperture of the camera.
Hold on. Through your eye. Lay down on the floor and look with your eye, and you can't see as far. Like if you're looking at if I put that
so at a certain distance away, my eyes fail me.
The angular resolution limits of your eyes make things disappear when the angular size of something gets too small. Okay, your eye doesn't have the ability to see anything above, below.
I agree with you. Say it again. I want you to say that all over again.
Okay.
For everybody else.
Your eye has an angular resolution limit of 0.02 degrees. What is that?
Okay.
0.2 degrees of an arc. So that's the angular size. Your eye can't resolve something that's small. Like if I showed you a penny, I think at like 100 yards away or whatever the distance is, nobody can see a penny because its angular size is too small. Okay, you can zoom in with a camera and make it bigger again, and now you can see it. So You lay down on the floor, you have your eye down low to the floor, you move that brick out 20 feet away, 50 feet away, 100 feet away, and you're going to see that brick. It looks like it's going to be sitting on the horizon because you're not going to be able to see the floor beyond it. You stand up, you can see the floor beyond it. You just move that horizon farther on a flat floor, not because you're looking over a ball, just because you raise your height, you raise the angular size, the angular size of what you're looking at. So getting back to the brick, you're laying on the floor, you got the camera or your eye, and you drag it away until you can't see that brick. Not on a ball. You have to pay attention.
No, this is what I'm trying to get this correlated, right?
You're looking at a ball, and that's what's wrong. That's what the problem is.
Well, we're seeing if we can replicate it on a ball.
If 100% you can. If I drag the brick over the ball, it would disappear beyond a physical horizon. Okay.
So this one works for the same for the ball and the flat Earth.
I haven't finished yet.
Okay, I'm just asking. Go ahead.
I haven't finished.
Go ahead.
Okay. Dude. So you drag the brick away, you can't see it. You stand up, you can now see it.
Okay.
You lay back down. Hold on. You lay back down, you can't see it. Now I'm going to stack 3 more bricks on top of it. You're laying down on the floor, you can see the second, third, and fourth brick. Now I drag it farther away, the second brick disappears.
Mm-hmm.
Okay. In your world, you're seeing over the curve of the Earth. In my world, it's just the angular resolution limits of your eyes. That's how it works. Okay.
So, but if we did this on a curved surface, it works the same way.
Absolutely.
It works the same way.
But here's the thing: on a curved surface, you have to have a physical horizon at no more than 3 miles away. If you're a 6 foot tall person, you have to have that.
But hold on. But we've already declared that we have physical limitations of the eye, which can only see a certain arc reference in distance, and that's what you're actually basing the flat Earth theory on, of how that actually happens. So that's the same thing as saying that we have a 3 mile horizon.
That's not true at all. I can sit on my beach where the horizon should be less than 2 miles away. I can see 5 miles across the Long Island, and I can see the beach over there. Okay, right? That's impossible on a ball. Okay, I can see way farther with a camera. I zoom in, the boat's gone. I zoom in, there's the boat again. I zoom in, there's the land again. Right, but there's also miraging happens. All sorts of things happen, and these are all optical things. Like I'm showing you here, these buildings disappear just due to the humidity change during the day. Look, the buildings are gone, the beach is gone, right? But it's still there. I mean, the camera's not moving, the land's not moving.
So that would be called a refractive index, correct? So that's because the light is moving in relation to an angular.
Is there a refractive index on the Home Depot floor at the distances I'm showing you? Absolutely not.
There could be. I don't know. It depends on the relative humidity. It's the middle of summer. Is it humid out? There's a lot of variation.
Home Depots are well air conditioned, and you know it.
Well, it depends if we're outside in the lawn and garden aspect. I don't know. I didn't do the experiment, so I don't know. Right? I didn't do the experiment.
That's why I tell you it's a Home Depot, because you can go do the experiment yourself.
By the way, everybody, this is my new favorite guest. I just hope everybody understands that. This is my new favorite guest. I absolutely love this, because this is good, because you know what? We're going to get into another part here, Dave, because it's irrelevant whether we agree.
Are we running out of time?
We're way over. We're way over time, but we're good. But listen, this is the way I look at it: is discussion is healthy. It's normal. It's good. I understand that people out there they don't like their beliefs attacked. That goes back to what we were just saying, Dave. Is belief is a limitation that we all need to evolve from. If we don't move away from our limitation of our beliefs, we never evolve as human beings, as spiritual beings, as whatever we want to become. And therefore, I don't have a standard belief. I wait for people to come and tell me that, hey, look, this is wrong and this is why. And there's some things that you've said tonight that I absolutely say, okay, you know what? I'm going to have to look into that, because Dave made a really good point. There's some things that I say, oh, you know what? I think I made a pretty good point, and Dave will probably go and look into that, right? And that's the thing, is we're not here to say one person's right or one person's wrong. We're here to share ideas, exchange ideas and knowledge, and see if we can grow as individuals.
People would think that this is the horizon here, but you can clearly see that the boat never miraged or anything. It's just reflecting off of this. As the horizon rises to eye level, it just becomes like a mirror, and it's mirroring the sky. So this is where the horizon is, this height. Everything below my finger is a reflection of what's above it.
Okay.
Okay. But this isn't the horizon. It's just the horizon is obscured in the distance.
Right, because it's a hot day, so the water's actually evaporating some. The sun's actually evaporating some water, so you have a water mist that increases the relative humidity right there at the surface of the water. Then you have the refractive index, the sun's angle coming down. It produces this thing where you kind of have that thing. But that happens on a flat Earth and a globe Earth. Absolutely. It happens on a flat Earth and a globe Earth.
You can't have, I've never seen bendy water. That's the problem. Large bodies of water at rest lay flat, right? There's no curved water, okay? Except large bodies of water at rest. Make sure you hear that part before you say, what about a wave? What about a raindrop? They're flat. We've measured with lasers over frozen lakes. We've measured with microwaves. Sonar on a submarine down at the bottom of the ocean across the abyssal plain can see another submarine 100 miles away. There should be a mountain over a mile tall of curvature between them. Okay.
Well, hold on. You're getting into my area of expertise here. We have over the horizon radars, and we have line of sight radars. We have line of sight sonar, which would be known as NIXI, and we have over the horizon or over the curve sonar, and all these work in various different ways. Now, line of sight radar is limited to about 50 to 55 nautical miles.
You have over the curve laser beams?
You can actually shoot a laser over the curve, absolutely, 100%.
Well, can you pinpoint a target that's over the curve?
Depends on your elevation.
No. Can you pinpoint a target that would be blocked by a mile of curvature?
Well, yeah, with my radar system, absolutely I can.
No, with a laser beam. Can you light up with a pencil-thin laser a target that should be a mile below the curve?
I don't know. I don't have any experience with that. What I can tell you
that because we have testimony from target guys on ships that say they can pinpoint, they can put a pencil-thin radar dot on a target over 100 miles away on an Earth curve of a radius of 24,000 miles. That would be over a mile of curvature.
Yeah, I'd like to talk to them because that was my level of expertise in the Navy, and we had never done anything like that, and I'd never heard anything like that done before in any of my experience in my 10 years in the Navy, and I worked on weapon control systems. Now, the thing is we can do that, but we do that with a syncopation of satellites. We do that with a syncopation of radars, where we have over-the-horizon radars, which basically take their electromagnetic energy, bounce it off the ionosphere, and that pushes around the curve, and you have a level of dispersion of that electromagnetic energy as it goes out. And then we utilize some type of satellite, whether geosynchronous or GPS, right? That would actually pinpoint and triangulate that target's location, and from that, we can actually target that location 100 miles away. Which I've done successfully multiple times.
So where are these satellites that you're talking about? Who put them up in space?
I would assume the Air Force has put them up in space because I've seen the launch pads at Kwajalein Atoll, which is an island that civilians can't go to.
Yeah. So did you know that NASA owns all the helium companies in the world, and they launch hundreds and thousands of satellites hanging from balloons? Okay.
Yeah, I've heard this. I've never seen any validation or proof of it. I've never looked into it too much, so I don't have much to say on it, but that's interesting.
Here you go. Here it is. They're launching one right here. And these are crashing all over the Earth in the app. What about satellites on the frequently asked question page? There's tons of videos of them crashing in like Brazil and different places.
So let me ask you this. That would mean that, so when they get up there, and let's say they're attached to a balloon, they're affixed to a balloon, and they're up there, all right?
Yeah.
Okay. Now, what's the distance that they're at up there?
They go different heights, and because there's different circular winds, and they can electrostatically, they can raise them higher and lower, and they can basically keep them in a circling over the same part of the Earth.
Okay. Now this is interesting because we have some of them that are actually moving like this, right?
Yeah. There's winds that circle perfectly around the
about
Earth.
20,000 miles per hour?
No.
So when I see these satellites in the sky and they're zipping through the sky, and I can calculate their altitude through other planes that I know that are sitting at about 30 or 40,000 feet. So these things have to be 100,000 feet plus. And when I see and I calculate their distance through the sky, right? Because I can look at them and I can say, hey, this thing just moved that distance in 1.2 seconds. I can know that if that thing is at 100,000 feet, it must be going this velocity because it moved that fast in that amount of time. Distance per time, right? So I can calculate how fast these things are moving. You can actually have my best buddy. We sit outside and we look at these things because we think a lot of them are UFOs, but a lot of these things are moving roughly about 19,000 to 21,000 miles per hour at that relative distance above.
Josh,
yeah, go ahead.
Josh, you you haven't thought it through. Okay, so you know how big a 747 is, right? Pretty damn big.
I
You
do.
ever stand underneath one? They're gigantic.
I've worked for an
Been in
airline
airports?
for 6 years.
Yeah. Okay, so they're pretty big. You're a little tiny speck next to it.
Yeah.
Put a 747 at cruising altitude. It's a tiny little speck, smaller than a pencil eraser held
That's
around
right.
a plane,
Absolutely.
and you could barely see it.
That's
If
right.
If you doubled the height, its angular size is too small for your eye to see.
100%. Now let's
Okay,
take that.
Hold on.
No.
Let me finish my point.
Okay,
Let me
finish your point.
Then you can go.
I'm gonna write
The
this one down.
satellites that you think you're seeing are 50 times higher, and they're smaller than a freaking car.
Okay, agreed. Now, hold on. Now take that 747 at that altitude, okay?
Yep.
And how fast does it move through the sky?
500,
Relative to me.
700 miles an hour.
Right, but we see it moving like what, this? Really, really slow, right? So it's at that distance. It's that big of an object, right?
Yeah.
And we see it moving really, 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 really small. But then we see these other objects that you're saying are 50 times that in altitude, and they're whipping through the sky.
No. According to you,
Right,
they're 50 times higher.
But that's what I'm saying.
I think they're much closer.
Oh, okay. So
And
you
I
think they're
don't-
much closer. But hold on.
And here's the only thing that we can say about them is that they're lights. We don't know what they are. They are definitely
So let me
they are unidentified.
So let's just say that these satellites that we see in the sky are satellites, as you're claiming, okay? And they're moving at really fast. How can I see them?
Because they're not.
How can I see them at night?
You're not seeing satellites.
No. You just said, so you said there's satellites up there.
I said there's these balloons up there. I don't think that's what you're seeing. It's possible you're seeing the balloon at a much lower altitude, but these other things that you're seeing, I have no idea what they are, and neither do you.
Okay, agreed. No, but hold on.
We can prove that they're not satellites. Because a satellite's the size of a car, and you can't see a 747.
I want to use some logic here.
At a 50th of that.
I just want to use some logic here to get into what you're saying about the satellite on balloons at a lower altitude, okay? Now, if this is true, and the flat Earth theory is correct, and we have the sun that is reflecting off of the dome here, okay? Then that means throughout the day, I'd be able to look into the blue sky, and I'd be seeing the sun reflecting off the top of these things. I would be seeing shiny little dots throughout the whole sky as these satellites. Oh, absolutely, you would. Secondly, to that, at nighttime, we'd be seeing the same thing, but at nighttime, we don't see that with these objects in the sky.
100% not.
The light's
100% not.
coming from underneath. We're seeing it from this perspective. The light's right here. The sun is on the other side, or the sun. I don't know. The sun's over here or something. So how does that all?
I don't think that you can't see the sun even. I don't think you can see the sun when it's on the other side of the earth, even at altitude. I don't think its throw of light goes that far. I mean, looking at the optics of the sky are no way to. I mean, as Crow 777 says, the only thing that we can say about these things we see in the sky are that they're lights. We don't know how big they are.
Okay.
We don't know how far they are. We don't know what they are. Okay. If you look at like Jupiter's up in the sky tonight, it's the brightest thing in the sky next to the moon. And we're supposed to believe that it's this dusty, dirty ball reflecting a distant sun where, it's supposedly this, which is insane.
Mm-hmm. I've seen that.
And then this is a cartoon.
No, I've seen that. I've actually seen that through my telescope. I got a Celestron 500 upstairs. So I've actually sat here in my backyard and looked at Jupiter and Saturn.
Yeah. You're seeing
Mars.
Jupiter, and it does have these little lines and stuff, and it is.
And I've seen the moons,
But you don't know how big it is. It could be the size of a beach ball.
It could be.
You don't know how big it is. But
it's definitely not that little flatter atmospheric dispersion stuff that other flat earthers are showing, right? It's definitely not that. Not that water droplet that they're showing, kind of like just reflected off and going like this. I've actually seen this. Yeah, like that. It's absolutely not that.
So no, it's definitely not. But if you look at it, you don't know what it is. But But if you were on Jupiter, the sun is smaller than we see the sun because it's farther away. So now you have a smaller sun lighting up a non-reflective gassy ball that's reflecting back to Earth, and we see it brighter than any star.
Why is it? Well, hold on. It's actually the light from Jupiter, right? Saturn, Jupiter. So you said they don't give.
No, they don't. That's what we're told. I think they are their own lights because that's the flat Earth model. Well, but in the heliocentric model, they're just reflecting sunlight.
Yeah, they're reflecting sunlight. So that reflected sunlight hits our atmosphere, and that's what we see, right?
You know what the inverse square law of light is?
I do. Very familiar with it.
Okay. So as light travels, it spreads out and it gets weaker and weaker.
Absolutely,
okay?
100%.
So you have a distant sun lighting up a non-reflective surface.
Why do you say it's a non-reflective surface? I just have to ask that.
They tell us it's a gassy planet. It's
so gas can't reflect light?
Well, not as well as water.
But it absolutely can. But we're also talking about electrical ionosphere on the outside edges of its atmosphere, which is electrically conductive. So therefore, we would have a reflective medium.
Let's go. We'll make it easier. We'll look at
the moon. Let's go.
So I gotta interrupt you guys. I gotta bounce.
Yeah, dude. See you, man.
Really, really great, Dave. It was nice to meet you. I appreciate you taking the time.
No problem, man. So this is the moon that they tell us is this dusty, dirty ball, and this is the sun, the moon on a clear night. You can read a newspaper by the moon in the middle of nowhere, and it casts shadows on the ground. It's so bright. So if this was one lumen, just one lumen, if you went halfway to the moon, it's 4 lumens. Halfway to that distance, 16. Halfway to that distance, 64. If you go all the way to 100 miles from the moon, it's tens of millions of lumens. Well, the sun that we see from Earth, I don't believe it's I forget what it is, but it's less than that. It would be so bright, but right here, we have to believe that this amount of light is coming back to Earth.
Yeah.
Right? It doesn't add up.
But I agree that I don't think they landed on the moon. But the fact that they landed on the moon or not landed on the moon does not validate a flat Earth. Now, the cool thing about the moon in the sky is if you actually take the reflective angle or the reflected face that the moon is reflecting light from in the sky, it points directly to where the sun actually is. That's a very cool fact right there. I don't know if that works and fits into that model.
Well, it sort of does. I believe that the sun and the moon are electrically connected and the sun's energy is lighting up the moon, but you're wrong. Every month for about a week, it does not line up at all. And
no, I didn't say that it lines up. I said that when you look at the face of the moon that is illuminated, that face of the moon is directly pointing to the position of the sun. So if I go outside and I look and I see a waning gibbous, right, and the right side of the moon is lit up to a half a moon, that means that half of the moon's context is pointed directly towards where the sun is. Usually you're going to see that midday, late afternoon when the sun is setting, because that's the time of day that you're going to have that waning gibbous moving into a waning crescent, is when that sun is moving, and it's the angular motion of the Earth actually going around, that when the sun moves and sets at various distances, that produces that crescent.
So you're saying the lit up side of the moon
will always point towards the sun. Yep.
Will always point towards the sun.
Yep, 100%.
100%. I'm just stalling as I'm trying to pull up.
Well, unless we're talking about a new moon where the moon is in front of the sun, right? Obviously, that doesn't work in that context because it's the reflective light off the Earth's atmosphere back to the moon coming back towards us, right?
How come during a total solar eclipse, nobody can see the features on the moon? How come during a new moon, no one from any position anywhere, aircraft, infrared, whatever, telescope, has been able to find the moon? Don't you think that the Earth shine, just like moonshine, would light up the moon? Because from the moon's position, from the moon's point of view, the Earth is a full Earth, and the Earth is 6 times bigger than the moon. I would think that the Earth shine should light up the moon, but no one has ever seen it. So, again, I don't believe that the moon that we see is the actual moon or the sun that we see is the actual sun. I believe that the light from the sources is above the firmament, and it's being projected in. And during a new moon, there's no light being projected, so there's nothing to see. That's how it completely and totally disappears. Oh, here we go.
Yeah, show me.
Sun, moon, not lined up.
Well, yeah,
you can see this yourself every month.
It actually is, but I think the picture's pretty deceiving. I'd have to look at the context of the picture and everything like that, but
just you'll see it every month.
We're also looking what time of the month. Tell me, I'll look at it. But that actually is.
This is a waxing crescent.
It's a waxing crescent, absolutely.
Yeah.
And what you're seeing there is the back quarter of the moon is actually pointed towards the sun. So the moon is actually, if we're looking like this, see, we're looking at it right there. We're looking at it in a linear fashion, right? But the moon is actually right here, and the sun is right here. And that's why only that top part of the moon is illuminated, because the sun is actually over here. But in the sky, they look like they're both right here. But in actuality...
wait. Are you saying that the Earth is eclipsing the part of the lit moon? Is that what you're saying?
Wait, hold on. What do you mean? That the Earth's shadow is reflecting onto the moon?
Is that what you're saying? Because that's not the case. Please don't say that.
No. Show me what's happening. Show me what's happening.
The moon is the moon is its own light. That's it. Okay?
Then why is 75-90% of it dark?
Why does it light? Why is it dark? Because it goes through these phases. When you say a new moon, why is it called a new moon? Right? Why is it called a new moon when it's when there's no moon?
The new moon. The moon's in the sky. It's out during the day. You can actually go out in the daytime and see the moon.
No, absolutely not. When the moon goes new, when the waning crescent disappears, nobody has ever seen the moon in less than 40 hours, which is almost 2 full days. Okay, no one has ever seen it. You can look it up. Let me show you a quick thing that I meant to show you before. So on the app, check this out. If you're in the middle, right? Anything inside of the Tropic of Cancer, which is this inner circle. Mm-hmm. So this is everything inside that is the north. The north is the Arctic region, and the south is the Antarctic region. You with me?
I'm listening.
You gotta look. You gotta look and listen.
Okay.
Okay. So on a ball, the Antarctic and the Arctic should be pretty much the same. The tropics are again in between the two lines. Well, anyone in the north, what does the sun do? Look, it's arcing around them. That's the Arctic. And if I'm standing out in the south of Capricorn, either South Africa or Antarctica, the sun is not arcing around me. It's antarcing. It's coming towards me, and then it's moving away. That's why it's called the Antarctic. The Arctic is in the middle because the sun arcs around you. The Antarctic is on the outside because it's antarcing away from you. On a ball, it should be the North Arctic and the South Arctic. But they're calling it the Arctic and the Antarctic. They always tell us what the truth of this world is. I have a Bitcoin challenge. I know you like crypto.
Yeah.
I'm offering 3 Bitcoins for 1 globe proof. Okay.
1 globe proof. But how about this? Let me ask you this. What consists?
How are we going to determine it?
What consists of a globe proof? Unless I take a rocket ship and I fly up there and I take a picture of it for you.
Well, a globe proof would be prove the horizon, prove curvature. I don't know because I don't believe in the globe. Prove that there's axial rotation. But and again, it's not just up to me. If I can't knock it down in 1 sentence, you can go on. We have a couple shows that you can go on. You can present, and then a board of people will just explain to you, hopefully calmly, that why your assumption is wrong. 3 Bitcoins for 1 globe proof. But before you do, here's what you do.
Yeah.
Every day there's a new featured video. I say you have to watch the video every day for 2 weeks. Just click this right here and watch the featured video. And then at the end of that 2 weeks, if you have a question, hey,
we're still on the moon thing, so we can't.
Yeah.
Oh yeah, there you go.
So
people weren't seeing what you're doing.
So there. Oh, okay, no problem. There it is. So you have the featured video on the bottom left-hand corner, and then if you think you have a proof of the globe, before you send it to me, you got to click the question mark. Up come the top 21 questions. Hey, what about eclipses? What about seasons? What about ships over the horizon? Like if I hit ships over the horizon, YouTube will not serve you these videos. These are videos. And again, this is what got me. This is what made me go out and buy $1,000 worth of equipment. And I started zooming in on things that I couldn't see. They won't serve you these videos because they don't want you seeing this stuff because they don't want you going out and verifying it yourself. These are awesome videos. All sorts of stuff in there. And again, it's 3 Bitcoins.
Awesome. Cool. So the way I look at this is that, I hope everybody learned something tonight. And that's the most important thing here is I'm kind of I'm not set in my ways because I think that belief needs to be non-limited, that we need to extrapolate from our current paradigm and from our current ideas. And I think that Dave agrees that not just me, but him as well, is that, hey, look, I don't think Dave wants to be a flat earther. I think he wants to be proved wrong. I don't want to be a globe earther. I want to be proved wrong, right?
I just want the truth. I don't care either
We're
way.
Truth seekers, and that's what really matters here. And, Dave, I know we're over time. That's okay. I want to just quick
Let me
announcement.
explain the why, though. We have to talk about
we're
the
gonna get
why
into the why
really quick.
We're gonna get into the why.
Okay.
Let me make a quick announcement. So, guys, Fringe After Dark, our subscription show, we'll be doing 30 minutes after this end. Approximately 30 minutes after this end of this show, we'll go to Fringe After Dark. And if anybody's interested in that, go to redpills.tv, and you should have got an email if you were subscribed. If you go in there, you go to the More button, and you go Fringe After Dark. It'll take you all the information on how to get that subscription. If you go to our platform, socialredpill.com, you can join in there, and people in there can definitely point to how to get in there. Just ask a question on the platform, and we'll definitely get it in there. Okay, now, and this is where the thing is, I think that Dave and I are going to agree a lot more, is if we pull the science and this whole aspect of what we live on. Because at the end of the day, Dave, does it really matter what the hell we live on, whether it's a globe or it's a flat Earth? I think it does. Oh, well, I was going to say that it doesn't. I think it's more about why.
It's not the shape that matters. You're
That's
right. It is more about the why. The shape doesn't matter. The fact that that doesn't matter. What matters is, I think you're aware that everything you have in your life, Josh, is because of the way that you think. You attract how you are. Negative people have negative shit in their life, and positive people bring positive shit in their life. And people that, focus on abundance properly have abundance, and people that focus on lack attract lack. Yep. That's the way it is. They don't want us to know. When I say they, these are the controllers of this world, which are, the Bilderbergs,
the Archons, whoever the hell might be.
All of this shit. They don't want us to know that we are at the center of creation. Before I discovered flat Earth, I was a full-on atheist. I believed we evolved from pond scum. I believed in the Big Bang. I believed it all. But then all of a sudden, I was forced into understanding that there is a creator. And now your relationship with the creator, whatever that is to you, I don't want to hear about it. That's your own personal relationship, and whatever label you want to put on it. But you cannot deny that there is a creator, because this world is intelligently designed. So why would they lie? And the answer is because they limit your thoughts, right? Yep. They limit your thoughts because we're just on this globe and there's nothing left to explore. We're running out of water. Not true. There's infinite water. We're running out of helium. NASA stole all the helium. There's tons of helium. We're running out of food, water. They're afraid of nuclear bombs. None of that stuff is real. None of it. It's all to keep us in fear. And then here's the good news. The good news is we have free will and they're not allowed to break it. So they tell us what they're doing. They always tell us, and if we're too stupid to say no, we're willfully giving away our divinity. We're giving away our power. Nobody, no government, nobody has power over you unless you give it to them, right? So the only thing that the only power they have is in your imagination. That's a fact. Imagine if everyone listened to this podcast tonight and tomorrow they go, you know what? That Dave guy is not only good looking, he's really smart. Okay. And
love it.
And they say, you know what? I'm done listening to government. Well, government's done. We won't even know who they are. We won't, because they'll be finished, right? It's over. And then, so there's two ways they control us: by controlling our minds, by having us, living on this sphere where, it's crazy. They're spinning out of control on an infinite speck in a godless or distant God universe where an asteroid could take us out. That's not a very good place of foundation versus standing on at the center of creation on a firm foundation where you're connected and part of the Earth system, not the soul lure system where they're trying to literally steal your soul. Okay. They're literally trying to steal your soul. This is a spiritual war. They don't want you to know it. They don't want you to know the power that you have. They don't want you to know the amazing place that this is. They don't want you in a situation where you have no choice but to not. They don't want you in a situation where you can't deny the creator. Okay. I used to deny the creator. Now I can't. Even if I wanted to, I can't. Okay. And then the other way they control us in that system of fear and lack and unempowerment, unimportantness, they control us with their fake monopoly money. Look at our money. They're telling us our money is the same color as the monopoly money. Okay. The colors on all of our 1s, 5s, 10s, 20s, 50s, and 100s are the same as the monopoly. Look at it. And the 5 is pink, whatever. And in the game of Monopoly, you know what it says if you run out of money? If the bank runs out of money, just get a pad of paper and write some more money down. Well, that's what's going on in this world. We need to get away from their money, and the best way, sound money, is crypto. Not all cryptos. I'm a big into privacy cryptocurrencies, not the ones that they can get their hands on. Money like if I paid you in Monero or Darrow or a pirate chain, nobody would know that you have it. No one would know that I gave it to you. It's fair money. there's all sorts of stuff out there. I know you teach some crypto stuff.
Yeah, we do
Awesome.
crypto masterminds. Yep.
Yeah. So, and I tell people, if you don't know what crypto is, maybe you should just spend an hour or 2 hours a week or an hour a day and learn about it. And then one day you'll be like, you know what? You'll be ahead of the curve. Flatten the curve, right? It's going to happen, right? So again, once you start looking into all of this stuff, once you get your head out of your rear ends, put your big boy pants on and realize, okay, they're lying to us about everything, okay? Maybe they're lying about who we are, where we are, what we are, the power of our mind. And the final thing I'll say is, it's like the movie, I call it the documentary with Keanu Reeves called The Matrix.
Yeah.
At the beginning, he's depressed. He doesn't know, something's wrong with the world, right? He can't figure it out. And then he unplugs his mind from the Matrix. He sees reality, even though it's a crazy, horrible looking world. But look at Neo at the end of the movie and put him next to the Neo at the beginning of the movie. And that's where we are right now. Okay. When you wake up to this, it's unbelievable. Next week, October 22nd and 23rd, this coming weekend, after this weekend, is Flattoberfest in South Carolina. There's people driving all across the country. Anybody that can go there, there's going to be hundreds and hundreds
driving around
and hundreds
the curve
of awake people. There's no curve. It's a straight shot. Okay. I'm driving 13 hours and I'm going uphill the whole way. Okay. So, if you want to know about that, it's in the app, but it's also, flatearthfestivals.com. Awesome time. Second day is a music festival. You're going to meet all your new best friends there, and there'll be just amazing things to talk about.
I absolutely love it, man. I think you're an amazing human being. I think that this was a good conversation. And look, I think we agree to disagree. I think we can agree on some things. We can disagree with some things, right? And that's okay. I got some questions for you, though. We got some questions.
Go ahead. Oh, no, I'll take some questions, but first, just note, I have actual video footage from a balloon with a flat, non-rotating plane. You have a cartoon behind you. Just pointing that out. Let's go with the questions.
Well, hold on. I do have a cartoon behind me.
Okay.
Now yours, I don't know what that video is behind you, because I know that's a cartoon though.
Okay, and I know that this is real, but
did you take it? Did you take it?
No. I know the guy who did take it.
No, but did you take it?
No. But I know the guy that took it. Oh. And we watched the entire video, and I took the clip of it that I wanted. And there's hundreds of them. Again,
that's awesome.
That's
cool. Hey, that's cool. But that's cool. I wasn't there. I'd like to see the whole video. Maybe you can share with me.
Son. Yeah. Dwayne Kellum. Check out the Dwayne Kellum.
You can hit me up with it, and you can show me and be like, "This is why." And I'm like, "Okay, cool."
Here's the thing: the app has everything in it. Get the app. It's $3. Oh, he's here selling an app. It's $3.
But you know what? I like this. I like this. This is how I operate, right? So Jason McQueen wants to know, why do tornadoes, hurricanes, drains in the water and drains, toilets move in counterclockwise rotation north of the equator and clockwise in the south, matching the Earth's rotation?
So that is not true. The myth that toilets and sinks go into opposite directions. The guys at the equator that do their little thing where they walk 10 feet over the equator, it's just the way they're pouring the water into the bin.
No, Dave. I've been there. I pissed in a toilet in a Navy ship south of the equator.
I have one toilet that goes one way in my house and one that goes another way in my house. It
depends how I piss, right?
It's the way the water goes into the basin. Sometimes my kitchen sink goes clockwise. Sometimes it goes counterclockwise. Now, as far as the winds, the tornadoes and hurricanes, the wake of the sun and the moon in between the tropics pushes the electromagnetic push. It pushes things, and they generally go in opposite directions. But every year, there's many times where storms will cross the tropics, spinning in the wrong direction, which totally negates the spinning ball theory. Right? It's like push your hand or a paddle through some water and watch. You'll have opposite rotating vortices on each side of the paddle. Go ahead. Next question.
All right. I'm asking real quick. We got viewers in here from Australia. So I just told them to go flush their toilet and let us know. Colleen Mazzani wants to know, if the Earth is flat, are other planets flat too? And why do rainbows curve?
Rainbows curve because the sky is curved. The dome is curved. That's my belief. And are there other planets? I don't believe in other planets. This is Mars. When you zoom in on Mars, It's more like an energetic source. It is its own light. Again, look at the light coming off of Mars. It's not what NASA shows you. NASA shows us these ridiculous pictures. Here's a picture from NASA's website from the rover who happened to get a little selfie of himself. That's how you know it's real. You can't fake this. And here's a picture from Greenland.
I'm not lying. Yeah, I'm in agreement with you that a lot of the Mars stuff, a lot of the new stuff, absolutely.
All of it. Mars is not. There's
and we can talk about why in a minute. But yeah, go on.
Yeah. So there are no planets. Planet is just plain with a T added to it. That's not the case. We're not a disk floating in space with other balls. Everything that we see in the sky is within the Earth system.
Okay. Gotcha. Heather Espinoza wants to know, if the Earth is flat, why haven't people fallen off the edge by now?
Could you fall off the edge of a lake? If you're on a lake and you sail around the lake and go around all the islands, and then one day you decide to sail to the end of the lake, can you fall off the
onto the surface, or you fall onto the edge, right?
The land. That's Antarctica. And what's beyond Antarctica? We don't know. But in the app, if you click "What about Antarctica?" there's a list of videos that will blow your mind, worth the price of the app right there just for those videos.
Okay, so Ancient Star Queen asks, why is it when people look through a telescope to see other planets, the other planets are spherical? Yet we see flat while everything else appears round. Yeah, we are flat while everything else appears. So it's the same question.
As I showed you earlier, you don't know what shape these are. Anything unless you can touch it and measure it, you don't know what shape things are. And even if they are, like on a pool table, the pool ball's are round. That means the table's round. The lights in my ceiling are round. That means my floor is round.
So I got you.
It's a correlation fallacy.
Shasta77 asked, does the app have a simulation? And I think you showed us that it did.
Yeah.
Okay.
It does. It does not just don't buy the app. Just go read the reviews in the Google Play Store and the Apple App Store. Except for the couple people that have like an antique phone and it doesn't work.
But if you do buy it, he's giving me 50% of everything. So just remember that. I'm joking.
Do you believe in the International Space Station?
I have problems with that, man. I have a lot of problems with NASA and everything that NASA's doing. And like, I told you we'll talk about that here in a second with the whole. I've seen the videos. I agree with you. Okay. But hold on. So we'll talk about Mars and NASA and all that stuff in just a minute. Let me get through a few more questions. Pammy Pam Pam asked, then wouldn't the sun always be shining at the center all year round, but in Alaska the sun only stays above the horizon during the summer?
So during the summer, the sun goes away from you. So in Alaska and Norway are in the center. So if I bring this to summer to where are we? March, April, May, June, the sun is very close to Alaska, okay? So Alaska is right here, and the farthest the sun could be from Alaska is over here where it is right now, and it's still close enough to be up in the sky, and then it just comes around, and it never sets. Only when it goes away, when it moves away from Alaska, away from the center, out here, now it's nighttime in Alaska because it never gets close enough to the inner north.
So, Dave, I got a question about that. I just noticed this. Move that sun in towards the inner circle again.
Yep. Now, by the way, the light and the dark on this, there's a big gray area. It's not.
I was going to say, because that arbitrary line isn't in relation towards the distance of the sun from the center. It doesn't move so if the sun moves towards the center, the light actually doesn't.
It does. If you look right now, Alaska and Norway, they're going to stay in the light because the light just goes a little bit.
No. What I meant about is when we were talking about earlier is if you look to, like, if you stop it right there, if you look to 10 and 12, the light extends out more of a distance than it does from 6 to the middle. And when you move it towards the middle, the light doesn't expend over the center as you would imagine it would.
So watch it. There's more dark than there is light. But if I move it to the equinox, to the equinox, August, September, now it's about 50-50 because it's equal day and equal night all around the Earth. Then I move it out farther, and the light will wrap around the dome, and we have these longer days in the south. Next question.
Yeah, and so Sean Hawkins asks, why doesn't the sun change in angular size over the day? Your model there demands that it does.
It does. It depends on where you see it from. And again, he's a well-known troll. But here's one where it just,
Sean.
It just shrinks as it goes away.
Okay.
But again, Give me a second. Let me really answer this question for you. It has to do with the way that we see things. So this train car, as it goes away, is shrinking, just like Sean is saying that the sun should shrink. Okay. So it's shrinking because it's moving away. You with me?
Okay. Yeah.
All right. So the sun is already moved away from us. So these lines are all level, but over here, you see that they look like they're going down, but these are level lines in the whole, this is a hallway. Okay. But look how it looks like they're going down here. So here's the same thing with the sun. This is an orthographic view, but this is the guy's view. We're looking from behind him, and the sun's going to start moving away, and it's going to start going down. Ready? Here it goes. Come on. There we go. So this is how he sees the sun, right? This is what he's seeing because the sun's just going away. You never see yourself from the orthographic view from the side, and then it just converges with the horizon. So here's the sun up here. It's already small. And as it moves away, it's not really getting much smaller. Add that on top of some atmospheric magnification that goes away, and you have these variations. Here's a ball, and 6 feet away is another one. It's the same size, but it's smaller because it's farther away, right? Right, here's the ball. Same ball is at the other end of this tape measure, right? And it's smaller because it's farther away. But if we lift the camera up and make the first one without getting any closer to the second one, watch what happens. Okay? We lift up, and both balls become about the same size, right? I'm not getting any closer, and it's because it's already far away, it's already shrank. And then add atmospheric magnification in there, which is a real thing.
But if I measure the sun in the sky, so if I measure the sun at noon, and I measure the sun at rise and sunset, isn't the sun going to be the same size if I measured it?
Close.
It's always going to be the same size, right?
No, it changes at times because the sun that you see, just like I showed you with the train car, I stacked them up. The top one was already small, and as it went away, it's just going down. Its angular size.
Because I know if I look at like the supermoon that's in the sky and I measure it, and I sit there and I measure it in front of me and I look at it in the sky, they're actually the same size. It's just the illusion of the magnification.
100%. And that's why here's something for you guys to do. Go on the next time there's a full moon on the horizon and it's gigantic. You're like, oh, wow. And you take a picture of it. And it's like, oh, that picture sucks because it looks tiny, right?
Yeah.
Because it breaks the illusion. Turn around, bend over, stick your head between your legs and look at the moon upside down through your legs. And it'll be tiny.
All right.
Because your brain short circuits.
I gotcha. So we got 9 minutes. I want to get into this last part. That was the last question. I want to get into the last part right here. So I said, like, the whole Mars thing, the whole NASA thing. Listen, I think that our universe is a lot different than people perceive it to be. This is why we have fake NASA, as people have seen. This is why we have, fake Mars pictures out there. Is whatever's really out there, they don't want us to see, and that is kept from us as a system of control and a system of occultism to keep knowledge away from us, because knowledge empowers us to be more than who we actually believe ourselves to be right now. Now, me and Dave were talking, and I think that's the one point that if there's anything that Dave and I are going to agree on tonight, it's absolutely going to be that NASA lies. I question the moon landing. I know the guy who built the last rover that went to Mars. Okay? I know him. I know him.
Hold on. You know the guy that built the last rover, you said?
Yeah, the last rover that went to Mars. But here's the thing, I question everything that happened. I don't believe it went there. I don't know.
Okay, so there you go. I'm saying, all right, I'll take your word for it that you know him.
Yeah.
But you don't know that it went to Mars, and neither does he.
No. Oh, exactly. That's my thing, is we can sit there and correlate directly these pictures that are being taken on Mars, and we can see them in Arizona landscapes, Utah landscapes, and so forth, just like you were showing. And I agree that is a questionable phenomenon, and we got to sit there and go, what the hell is actually going on here? I think even in one of their photos, we saw a Coke can, right?
And a squirrel and all sorts of stuff.
Yeah.
And mushrooms. Right. They found mushrooms growing on Mars. No, mushrooms are growing here on Earth.
Right. And this is the International Space Station, of how they do it in water. They actually, that new movie, that new Disney movie, the documentary one, they actually show how they filmed the movie in the water working on the International Space Station. Like, well, did they go to their own set or what,
Right. So you know about the National Buoyancy Lab. That's where they have a space station underneath water, and that's where they do all of their
absolutely could see it be true. Absolutely could see it be true. Although it does not equate that the Earth is flat, it does show that there's something wrong and there's something going on.
Right. And one other thing, next time you're in an airplane, an airplane flying at 39,000 feet, the horizon should be 78,000 feet below them. And it's not. It's out the left window, it's out the right window, and it goes right between your eyes if you drew a line. And it should be 78,000 feet below you.
I'll have to check that out next time I'm in a plane.
Yes, definitely.
And do the math.
Do the math. Yes. And the National Buoyancy Lab, you ever see this painting up here?
Yeah.
So it's a guy, a Vitruvian man, inside of a dome with a rocket trying to break through, scuba diver handing him a friggin' power tool. And that's exactly what we see. You know, that's what's going on during these walks. Yeah.
And I cannot prove or deny that, but I can definitely tell you that there are problems with everything that NASA says, everything that we've seen from the Mars missions, the moon missions, absolutely 100% in agreement that there's something going on. Now, what do I think is going on? I think a lot of what's going on out there has a lot to do with what's going on right here, right now. Everything from COVID to the vaccines to the elections and to the tyranny that's happening throughout the world, the suppression of who we truly are. Now, I think another one thing that Dave and I would agree on is that we are much, much more than just humans who live on a rock or flat or whatever it might be, that go about our daily grind. We spend money, we live, and we eat, we shit, and we die. We're way more than that. And I think that's the key here, is everything that is happening right now in the world is meant for us to wake up to the true realization of who and what we really are, to unite within that power, within that glory, and really rise up and take back control over our reality, which has been hijacked by someone or something.
Right. And they've divided us when in truth is, in the 1800s and before, there was a worldwide advanced civilization here. Not even that long ago. This whole deception is less than 100 years old. And they don't want us to know the division of countries. They divided us by countries. That's not real. They divided us by genders and sexes and sports teams and politicians and vax, unvax. They're divide. Now they're muzzling us and separating us. This is literally trying to dehumanize us. And that's a whole nother podcast.
Well, you know what? We should have you back, and we should talk about Tartaria, the mud floods. We can talk about the infratoriums during the World Fair. We can talk about the French catacombs, of how there's about 400 million people buried under there at the time of the Earth's population was 4 million.
Wait, let me ask you a question.
Yeah.
Have you seen them yourselves?
I know people who've been in the catacombs, and I trust them with my life, so that they do exist. Are there. Do you know who Max Egan is?
I know. Yeah, absolutely.
Absolutely. Max, good dude, right? Max and I, we had a conversation about it. Ben Stewart is another good friend of mine. So we've talked about these things. Our group, we have a show Saturday nights called Makes You Think. You might actually want to come on to it. I'll see if a guy in them can get a hold of you and have you on there as well. And we can talk about a lot of these things. Okay. It's not my show, it's their show. But they go in deep. So they research topics, and they go in and they try to either show there's some relevance. It's usually like things like Tartaria. Right. So we go into Tartaria, we look at the mud floods, and, we look at DNA modification, a lot of things. But we know that there's something wrong with our history. And if we go back about 150 years, even if that even is the context of reality, but if we look at the history books 150 years, we can see major problems started to happen within the transformation of our history. That I do believe that we were a highly advanced ancient society, that the pyramids aren't 5,000 years old. They're probably like 250 years old, that we utilize various monuments on this planet. We were highly advanced in that we were so advanced that we didn't need this archaic technology, that we were able to manipulate the natural elements and forces of the universe to our benefit, but we did it in harmony with our planet. And so maybe that's another podcast that you and I can have, and we can discuss all that, because I think that'd be awesome.
Cool.
Awesome. Very cool, guys. Hey, guys, Flat Earth Dave right here, Dave Weiss. If you want to check him out, we can visit you. Dave, I got your information right here. I want to pull it up.
The easiest, let me just, instead of giving too many sites, flatearthdave.com.
Flatearthdave.com, right there.
Flatearthdave.com. That'll be the link to the app and my podcast and other stuff. If you want to dive into all of the other crazy stuff out there that people aren't talking about or allowed to, stoplookthink.com. Stoplookthink.com. But if you want to learn about flat Earth, you want to take the challenge, you want to have a good time, you want to find other flat Earthers near you, you can do that all on the app. You can message other flat Earthers that are near you. You can instant message them on the app and set meetups and gatherings and maybe meet your next special somebody.
Fantastic. Dave, thank you so much, man. I'm going to hold on right here while we go away. I want to talk to you for a few minutes. Everybody else would be heading in about 30 minutes. We're going to head to Fringe After Dark. That is our private subscription podcast that you can get to on socialredpill.com or redpills.tv. Just go to the main menu. You'll see Fringe After Dark. You can find the information about there. For everybody who subscribed to redpills.tv, you should have got an email notification with all the information on that. Other than that, we'll be back tomorrow with Makes You Think. And back with the rest of our podcast on Monday. Take care. Be well. God bless. We love you guys. Have a great night.
See ya.